Reflex is becoming one of my favorite ways to build Python applications for several reasons. One of them is its front end and back end all in Python, and the way they're coupled together is it's so nice. Now, the other reason about Reflex in particular is how well it integrates with other tools that I need. Something like OpenAI. Every once in a while, I'm going to want to bring in something like GPT. That's the point of this course, is to have a way to have GPT going on, being able to talk to it and do it all in Reflex. I'll show you a demo in just a second. But the idea too is not only do I want to be able to chat with OpenAI or Anthropic or any other GPT model that comes out or any large language model that comes out, but I also want to store the history of this data, and I want to be able to do it in anywhere that I decide to deploy. So the way we're going to do this, and the way it's even possible, is thanks to Neon. Neon and I partnered on this course because, well, they provide a way to store our data in a Postgres database. Now, if you want to get it more advanced, you can also use vector storage in here to do semantic search. We're not doing that in this one, but the idea with Neon, the way we're going to be using it, is we're going to integrate it into our Reflex project. So we'll store all of the standard web application things you would want to do within Neon with that. But then we will also use it to deploy our Reflex application. Now, we're going to be deploying it in a virtual machine. So using Neon and Reflex as well as Docker, we're going to deploy it to a raw virtual machine. The reason we do this is because once you know how to deploy to a virtual machine, with a Docker container especially, you can deploy it almost anywhere. And also thanks to Neon, the fact that it's serverless, we could actually bring it pretty much anywhere we want as well, including serverless runtimes if those ever support something like Reflex. So I'm really excited for you to actually check out what it is that we're going to be building. It's going to be fairly straightforward in terms of how it's executed, but it will give you another look into how to use Reflex and use something production grade like Neon. Let's take a look at the demo right now. Let's do a quick demo of what we're going to be building in this one. Keep in mind, everything that we write is all in Python. It might not feel that way, but it totally is. So if I break this down, I can actually see that it's responsive. I can go and chat with it. I can go and create a new chat. Notice that that chat went away. Let's go ahead and say something like, give me a recipe for beef tacos. I love beef tacos. Let's go ahead and do that. What it's going to end up doing, of course, is calling OpenAI. It does take a little bit of time, but overall the idea here is once it's done, it comes out and it's formatted using Markdown. This is all run through Reflex and Python and Neon to store all of this data, and then OpenAI for all of the API data, which we can see on Neon. We can actually jump in here into our recent table where we can see, if I refresh in here, I can actually see the data that's coming through, give me recipe for beef tacos, and then the system response is also stored in there as well. That is this entire response. This whole thing is going in there. Oh, how about for 30 people? Right? Quite a bit different of a recipe then. And of course, the response will actually come through. And there we go. There's a recipe for 30 people. I would imagine this is probably fairly accurate. Now, if you're a chef, please let me know. But the idea then is all of this code is written through Reflex, and it's fairly straightforward. So what we do here is we create a form. This is a very straightforward form. I'm not writing HTML. I'm not writing JavaScript, none of that. I have an AI stuff. This AI stuff is really, really simple. You could always flip this out for something like LangChain or Llama Index to do these things a little bit more, let's say, for instance, flexibly. So if we wanted to use a different LLM than OpenAI's. Then also we have all this state stuff. This is a little bit more complex than what we've seen, but this is how we can actually integrate the front end with the back end in a very seamless way. Also using SQLModel, which is very popular in terms of just raw SQL, almost raw SQL, using things like Pydantic. As you can see here, here's a chat session model, and here's the chat session itself. Now, some of these things are going to be maybe complicated depending on your background, of course. But if you're familiar with SQLModel, this is going to be very, very straightforward to you and hopefully excite you about using Reflex itself, because you can build user interfaces really, really fast. Here's a standard about page, for example. We come in here, we click on about, there's my about page. Granted, it doesn't have a whole lot of content in here, but how you build these pages is very, very straightforward, and there's a lot of documentation on Reflex to make that happen. Now, of course, in our models themselves, these are going to be our database tables that are then stored into our environment variables, into our Postgres database from Neon. That is all configured directly into Reflex as well, which we have right here. Then, of course, we deploy all these things. First off, we build Docker containers, and then we deploy it into a virtual machine using GitHub Actions and Ansible. So a number of technologies that we end up using. The deployment stuff is all towards the end. So if you're not that interested in deploying it, which I'm not sure why you wouldn't be, but if you're not, then you can learn a lot of the things about Reflex right now. So let's go ahead and jump right in. Let's start by creating a Reflex app. The way we're going to do this is by creating a Python virtual environment, installing Reflex, and then running Reflex itself. If you are Windows, I highly recommend that you use WSL so you have a terminal environment like this. Linux and Mac users, of course, open up terminal and you'll go ahead and make this happen. Of course, if you have VS Code or similar, you could always do it in there as well. I will be transitioning to VS Code here shortly. But let's go ahead and get this started by making a directory in my dev folder. As you can see, I'm in my user's dev folder, which I created. Then I'm going to go ahead and create a new directory here, and I'm going to call this just simply Reflex GPT, and then I'm going to navigate into Reflex GPT. Of course, the idea here is we're going to have a chat with an OpenAI API, so Reflex GPT makes a lot of sense. Next up, we're going to go ahead and initialize our virtual environment with Python 3.11, which is what I am using. You can use probably a newer version of Python 3. 3.12 is out, but 3.11 is supported by what we'll eventually use for deployment. So that's why I'm using 3.11, and then I'll go ahead and initialize a virtual environment this way. Now, of course, you may know there's a lot of different ways on how you can initialize Python virtual environments. I use this one because it's built into Python, and it has overall the best stability among all of them. But of course, there are modern ones that are faster, maybe a little bit easier to do some things, but get the idea that we're going to go ahead and use this one, and I'll go ahead and do source venv bin activate. Now, everyone, including WSL users, should be able to activate it this way. If you're on PowerShell, it's a little bit different, including using Python itself. Next up, once it is activated, this is when I can run pip install Reflex, and I'll also install pip again and upgrade both if I don't have those packages already. And of course, this is very simple. This is straightforward. This is very common with Python projects. And if you do need a different version of Python, feel free to go to the download sections of python.org and go through the download process for your platform there. Of course, there's a lot of different ways on how to install Python since it is open source. But of course, at this point, we now have Python installed, our virtual environment activated, and Reflex installed as well, so I should be able to do Reflex in it. This will initialize, of course, a Reflex project for me. Now, you can actually run this after the project has been already created, which is pretty cool. Now, in my case, you can see that there's a bunch of different options that you can use for the template. I'm going to be using 0. We're going to be doing a blank template itself. Once you go through this one, you can take what you learned here and apply it to many of these other ones. Because Reflex is Reflex. It's actually fairly straightforward, except these ones are a lot more advanced. So we're going to go ahead and start from 0. Now, with this in mind, I'm going to go ahead and do Reflex and run. This, of course, is going to run my Reflex application. This will compile things. It will also run and change this. It will recompile if I make any changes to my code, which I'm not going to touch just yet. But at this point, I'm going to go ahead and open up localhost 3000. And what you should see is eventually it's going to connect to the Reflex application running. And there we go. So we're now ready to start actually editing our Reflex application. Let's add it to VS Code and get that done. Now we're going to bring Reflex into VS Code. I'm going to close out my terminal with Control-C, and then I'll just do code period. Now, in my case, I have the code command line installed, which is how I can actually open up that folder. Of course, if you don't, just go ahead and open up VS Code, go to open folder, and then navigate to wherever you stored it. In my case, I stored it in this location right here under my user, under the dev folder. I'm going to go ahead and open this up, and then I'm going to go ahead and create this workspace. We'll save workspace as that. I'm also going to go ahead and initialize Git. So Git init. Now, if you don't have Git installed, feel free to ignore this part. But in my case, I have Git installed. Now, Reflex itself doesn't automatically just ignore virtual environment in their Git ignore, mostly probably to keep it very concise, and the fact that there are a lot of them out there. If I do Python, git ignore, I can see the default one from GitHub, which is usually the one I grab, and then I just bring it in here, paste it right underneath all of the Reflex stuff, and then I'm also going to go ahead and add a DS store in here as well. We'll go ahead and save that, and there we go. So we now have our project in VS Code, and it's ready for Git. Now, naturally, Git itself probably is already installed on your machine, but of course, if it's not, just go to gitscm.com and just go ahead and download it. It is cross-platform. Git is critical to tracking the changes with your code. The only time I'm going to do this is right now. I'll do everything else off of this video, and I'll go ahead and commit initial commit, and then I'll go ahead and push this into the Git repo, which you'll see at some point. Now we're going to take a look at how to create a new web page and route to that new web page based off of Reflex. Before we jump in, I will mention every once in a while I add files related to the Git repo that aren't in the video at all, like readme.md. This is just for the repo. So every once in a while you'll see that stuff. Everything that's relevant to the video will be in the video. Now, the idea here is we want to open up the folder Reflex GPT and the file reflexgpt.py. Now, these things came from the naming for Reflex GPT came directly from the folder I have it stored in, which of course is reflex-gpt, not underscore. And then when I ran Reflex init in there, Reflex automatically named the project based off of the containing folder. If that wasn't obvious, hopefully it is now. What we want to do is open up reflex_gpt.py and create a new component in here. So the idea is I'm going to go ahead and copy index right here, and I'll go ahead and paste it right above, and I'll just call this about us. This is going to be our new page, and this is going to be our about us page, like that. Great. So with this in mind, I'm going to go ahead and get rid of some of the elements that are inside of my page here. Really just welcome to Reflex about, something like that. And then on the index itself, I'll go ahead and do welcome to Reflex and GPT, just so we can see that things have changed. So now I'm going to go ahead and run inside of my terminal here. I want to make it clear that toggling this terminal is something I will do frequently in this video and throughout the series. So get used to toggling it. In my case, it's going to be the tilde or that tick. So if you do control tick, it will toggle it. And on Mac, I think it might be a little bit different on Windows. But the idea, if we toggle in here and run Reflex and run, hit enter, we should see one of these two pages. Now, of course, the reason we see one of these two pages, it has to do with if we scroll down, we can see that it only added one of those two pages. So what I want to do is I want to go ahead and, well, let's verify that it's running by going into localhost. I just want to see that the text did change, and sure enough, it did. And of course, we can always edit text right in line. So get started by editing something like, and we can see that, hey, what do you know? It actually changes these things in real time without me needing to refresh the server at all. So it's going to constantly do that, assuming you're actually saving the file itself. Once we have this understood, we're going to go ahead and go to the next part, which is adding a new page. It's literally taking this function of about us, this component, and passing it in just like that, and then adding something like route equals to /about. Now, the index function itself defaults to route / just like that. Now, the reason this is important is because if we changed index to something like homepage, you would want to make sure that that route is updated and is written in there. Me personally, I like explicitly having the routes so I can see exactly where everything's going on the application itself. Now, of course, when we actually go back to the application, nothing seems to have changed. So if I go into /about now, I can see, hey, what do you know? I have another page in here that I can actually navigate to and go back and forth. It's really just that simple. Now, of course, the problem that I currently have is the fact that I can't really navigate between the two of them on the actual page itself, unless, of course, I know about this page. So what I need to do now is I need to have a reusable layout that I can use on all of my pages. I want to do this early on so that it's a lot easier down the line to have that reusable layout. And of course, all of it comes down to this RX component. let's take a look at how we can build our own reusable layout right now. When it comes to Reflex, pretty much all user interface elements can be moved around or interchanged. Now, what we see here is the About Us page and the Home page all return RX component. That's because all of these user interface elements are based off of RX component, which you can also inspect on your own. So if you were to control click or right click on any given component, go to the definition, you can see that it says HStack is from this class, which we scroll up a little bit. We see that it's from stack. We go to that definition, which is up here, which comes from flex. We go to that definition. We can see that there's radix themes. We can go to that definition, and there's our component, right? So Reflex components, import component. So the reason I'm telling you about that is because we can move them around, but we can also design our own components that basically use the same elements that the default component does. Now, the reason for this is so that we can have a consistent, user interface or page layout across all of our pages. And that's what we're going to do now. We're going to go ahead and create our base layout. So I'm going to define base layout in here, and it's going to do the same thing, which is going to be RX component. And then we're going to go ahead and return back. Well, what do we want to return back? In this case, I'm going to go off of the container itself, and that's what we're going to return. So now, instead of RX container, I want to use the base layout, just like that. Now, if you're familiar with Python, you know that, I just called a function and I passed in some arguments to that function. So what we want to do then is we can bring in our base layout and we can do args and keyword args, just like this, and then pass it down into our container, just like that. This will actually allow us to have the same base layout across all of our pages. So if I go into About, it's the same. They both look the same. So that's actually really nice. That means that I can do all sorts of things with my layouts going forward, which of course is something we will end up doing. Now, the other thing about this is at some point we can put in our navbar, which I'm just going to go ahead and put in, rx.heading here, and I'll go ahead and say navbar like that, close it off. So basically we want to make sure we are actually closing off the heading. But if I do something along this layout, now if I see navbar and I go into About, that same sort of navbar element will show up. Now, of course, this is not how our navbar is going to end up working next or very soon. But the idea, though, is we can actually reuse these components and design our own whenever we want to. So like the logo or a stack that you want to have in multiple places, this is the idea. Is you can redefine it here. You can use it where you render it out itself. So let's say, for instance, let's go ahead and do define navbar. And again, I'll go ahead and bring in our RX component here. And I'll return back just the heading itself, like that. Now, I could put in args and keyword args in here as well as kind of a fallback, but the heading itself, or rx.heading, I'm not actually going to go ahead and use any of those. The base layout, I did. But now, inside of my navbar here, I can just go ahead and call this just like that. I call it like a normal function like you normally would in Python, and nothing really changed. But now I have two reusable components. One that we pass things into, the other one that we just call. Really, really nice. But of course, we can also pass things into this as well if we wanted to. So let's say, for instance, navbar, and I'll go ahead and say navbar. This time, I'm going to go ahead and do child, or let's go ahead and you could call label. You could do all sorts of things. Now you could actually go ahead and come in here and do something along those lines, and now it's going to go ahead and change what it says in there. Now, there's a lot of different conditions. There's a lot of different things we can do with this stuff all together. We're going to really focus on just getting that layout right so we can actually navigate between our different pages here in just a moment. Now, before we write all of our code in one single Python module, we want to actually parse things out so they make a little bit more sense in terms of our application. So inside of Reflex GPT, I'm going to go ahead and create a new folder called UI, and I'm going to create 3 files in here. The first one is the init file. I'll just go ahead and copy, and I'll actually paste it 2 more times. We're going to go ahead and do navbar.py, and then I'll go ahead and do base.py. So the base user interface that we're going to go ahead and put in are, well, base layout, just like that. And then our navbar, we're going to go ahead and bring the navbar element in there, just like that. So now inside of Reflex GPT, I'm going to go ahead and get rid of these navbar elements in here, and I'll go back into navbar .py first to just simply import reflex as Rx. And then I'll go ahead and do the same thing in base.py. And I will also go ahead and do from .navbar import navbar. And there we go. So I'll probably actually rename this to something more like navbar or like base navbar, something like that. So navbar.py, and the function itself is just slightly different. So the import, we don't have any issues in our minds of the import. And so there we go. We've got our base navbar. We got some of the imports done. Next, inside of init.py, I'll go ahead and do from.base. We're going to go ahead and import the base layout. And then we'll go ahead and basically export it from the UI module with doing all. So now I can actually import it directly from the UI module in Reflex GPT. In other words, back into Reflex GPT now, what I can do is from dot import UI, and then I can just do UI.base layout and UI.base layout. I'm essentially following how Reflex does their imports and how they can use their imports. Although I'm going to be quite a bit different because I just want to be specific about the different things I'll do. In this case, just that base layout. It's a little bit more organized, and it's going to be easier to then go, oh, I want to change the navbar itself, and just go to navbar.py. And then also when you actually put this into Git or version control, you can just see these small edits that end up happening inside of something like your navbar or your base layout. That's another reason to do it instead of one file having everything. So actually with this in mind, I also want to do one more thing, and that is create another module called pages. And this is another way to do it, which you created with a file and just do a slash and then init.py. Now I'll do the same thing with that, with about.py and home.py. So same idea here. I'm going to go ahead and copy this whole thing and bring it into home.py. I'll just go ahead and do our home page here. And I'll go ahead and cut that out. Now instead of from dot, I'll go ahead and do from Reflex GPT import UI, because that's going to be the main package itself. There's our home page. And so this same concept, I'll go ahead and do again with about.py and just go ahead and grab our GPT UI here. I'll get rid of that state. I only need about us, so I'll get rid of the home page and all of that other stuff as well. I do not need rxconfig in here. The home page, I think I still need that, so I'll leave it in for now. And then once again in pages, we'll now do from .about import our about us. And then from .home, we're going to import the home page, which I believe we called just simply home page. I should probably call about us the about us page, just to follow how we named the home page. And then once again, we'll go ahead and do all equals to the about us page and the home page. There we go. So now the main configuration, we'll do one more thing and do pages here. I'll get rid of the about us page and that home page. And now I'll use simply pages dot in both of those pages, especially because they are pretty static themselves. I don't need the state here. I will update that soon. Notice I don't even need the UI in here anymore or very many imports. So this is meant to make it a little bit more organized and very specific to our own project. Now, this is a stylistic choice, right? You don't have to do this. I just think it makes it a lot easier to manage things on my entire page itself. These are more of like static pages. They're not really dynamic elements like we'll see when we start doing the chat, but they do have a lot of really good stuff in here. So let's keep going. Jumping into reflex.dev/docs, under the recipes, we're going to go ahead and grab their recipe for a navbar. So I'll go ahead and copy this into the basic one. Of course, there's a bunch of other ones in here. I'm going to go into the code. I'll go ahead and copy that. And we're going to bring this into our navbar.py. Hey, what do you know? The reason we did this was for this right here. Now I'm going to change it from navbar to base navbar because that's what I called mine. And I'm going to go ahead and get rid of all of that in there. That's it. Back into base.py, I will no longer have that string going in because it's no longer necessary. But of course, if we save that, open up our project here, we will see now a different nav bar, a different navigation bar that's going through with this project. Now, this is the reason that I think Reflex docs are so good is that you can actually see what gets rendered out and then the actual code for it. Now, in our case, we don't actually have this icon in here, which is something we could, of course, solve, or we could just get rid of it, right? So source logo inside of our assets, we actually don't have that logo. I'm going to go ahead and save this image into my project just so you can see how it's done. So in there, we'll go ahead and navigate to our project into assets. We'll go ahead and save that file in there, and then we should be able to refresh in there, and there is that logo. So now we've got all of these different links in here, so we actually need to bring in some navigation. But the idea here is our About page should actually have About. It should have that same nav bar. And of course, we could continue to play around with how we want this to work. But in our case, I'm just going to leave it as is, and I'll just go ahead and change the heading itself to being Reflex GPT. Now, another thing that's nice is there's already built-in support for mobile. So I can break this down, and you can see that built-in support. Now there's this icon that's up here that we actually probably don't want to have anymore. That one is coming from potentially our container or one of our pages. So if we go into our home page here, we can see our home page actually has rx.logo, but it also has this color mode button here, which I don't want anymore. Granted, you could definitely have a color mode that's actually really cool that you can just toggle things really easily, but I'm just going to go ahead and get rid of it for now. You could always add it into your nav bar as you see fit. But in our case, I'm going to go ahead and get rid of it so it doesn't interact with the nav bar too much. There we go. So now I can see this drop down in here that has all of those same elements that we had as far as the items are concerned. But that's where the nav bar coming from their code directly, we can actually see all of those elements coming in here. So this, of course, is something we'll need to change. We need those links to actually work. So in order to do that, we actually want to build out another component. But the main thing here is the documentations on Reflex has a lot of different recipes of a lot of different things that you can do. Pricing cards, login forms, sidebar, footer. Let's actually see the footer, for example. So here's our footer. What will we do here? I'm going to copy this. I would go into my UI element here, and I'll call it footer.py. Paste this in. Now, of course, I need to import Reflex. So import Reflex as Rx. That's probably all I'll need, but I can take a look in here for that. This footer, I'm going to change it to being my base footer. Once again, kind of going off of the same theme that we've seen before. Now I can bring this into base.py and do from.footer import base footer. Oops, this should see that. Okay, so now underneath these args and keyword args, I'm going to see if I can bring it in down here. More than likely, it's going to be a syntax error, but let's go ahead and take a look at what's going on with our project. And what we see here is still base. Yeah, so we can't actually do that. So we have to follow Python convention in here. So like this. Now, this is where, what if I do want the base footer on the very bottom? This is actually a good opportunity to do rx.fragment and bring that in as our main arguments that come in here. And so that would allow me to bring those args and keyword args from our base container so that our base footer is actually a footer. And so if we actually take a look now, there is our footer. It's now actually being rendered out in here, which is actually pretty cool. Very straightforward on how it's done. Now, of course, we'll talk about the fragment more in a little bit, but it actually comes down to the actual element that's being rendered in terms of the container or the function itself. So the container turns into a div in HTML. This turns into nothing. This doesn't render anything, which is pretty cool. But now we've seen how to use some recipes just a little bit, and we've seen some fragments. Let's take a look at the next part. When it comes to all of our Rx components, all of our Reflex components in Python, yes, they are Rx components. Now, it's true that all of our Python functions end up being Rx components. Now, it's true, all of our user interface elements are Rx components. They're Reflex components throughout. But how they get rendered in the web browser is not going to be a component. That's too general of a term. Instead, they're going to be actual HTML elements. And we can take a look at how this actually shakes out by taking a look at any given element itself and then adding in ID equaling to, let's go ahead and say my, nav image ID. Something fairly unique to our entire project that won't likely show up. So now if I were to inspect the element in here inside of my web browser, and going into my elements and just do a Command F or Control F and search for that element, there it is right there. So notice that it's an image tag. That, of course, is because the component itself is rx.image. So this will actually get rendered out as an image tag itself. So img, src equals to logo.jpg and so on, right? So we've already seen that. Now, adding this ID will help us anywhere on our components, anywhere we might need to identify what individual components end up doing, right? So our footer, for example, if we want to go into our footer, let's go grab our footer item, privacy policy. So footer item's way up here. Notice that it's a link in there, and we can actually go ahead and grab that ID, and I'll call it my footer ID. Notice that it's going to be after any sort of components that I'm passing in, and also any arguments that I'm passing in. This is just one of those many arguments. And of course, if I refresh in there and do a quick Command and F inside of my elements here, there is my anchor tag. So rx.link is an A tag, right? A href, which is fairly obvious by how it ends up getting rendered out, but it's important to see that with your own eyeballs. So next up, we actually take a look at the text, my footer ID text, something like that. Save that. Once again, do a quick search for it, and let's let it finish rendering. And notice that it's a P tag in here for that text, right? It's a paragraph tag. And this is going to be true throughout our entire project. So it's important to understand that. It's important to know that how it actually gets rendered out is going to just be simply HTML. Now this actually brings us back to base.py and why rx.fragment is fairly useful. The container itself, if I come in after base footer and do ID and say my base container, I will be able to search for that base container in my elements, of course after it's all rendered out. There's that base container. Notice that there's a few other containers above it, right? So there's a few other divs above it, and all of this has to do with how Reflex is rendering out the actual HTML elements themselves, right? And so when we want to see our fragment in here, I'm going to go ahead and pass in our fragment as an ID in here. So my base fragment, save that, and I'll do a quick search for it. And we search for our base fragment, we can see that it is nowhere to be found. This is because it doesn't render anything. It just renders out the logic for all of the other components that might need to come in here. So this is kind of like a hidden component in terms of HTML. So many of the other ones are not hidden components. Fragment is pretty much the only one that is going to be hidden in the HTML, but will still render, logically will work out. Now the reason for that actually is well illustrated or encapsulated with this base layout, because that fragment just simply did not show up, but it allowed us to do args and keyword args. It allowed us to actually pass in other components inside of our Python function, which I think is critical when you want to render a component still, but not have it actually be a div or something like that. Now, of course, if I actually changed it to rx.box, for example, that is another component type, I can actually now, I should be able to find my base fragment, assuming I save everything, and it does refresh in here. So let's go ahead and refresh on this page. I'll do Command F for my base fragment. Looks like maybe I've got a problem in here with my base fragment. Oh, I should put a comma. And let's try that again with my base fragment and do a quick search. There is that box. So we actually see there's even a class for it already on there. That's why there's already styles on here. Reflex itself is attaching styles to all of these different elements. Once again, changing it back to a fragment. Let's just verify that again. I don't think I was missing that comma before, but let's go ahead and just do a quick search. Once again, it's missing. Cool. So fragment is super nice. Box is super nice. Container is super nice. They all have different elements as to what makes them important, many of which I actually went through on a different video, which you can see in the description. But the idea here is now we have the ability to start the process of actually having links. There are two ways that we're going to go ahead and navigate. One is going to be a standard A or anchor tag link, and then the other one is going to be on a click event. So let's start with the anchor tag because it's fairly straightforward. but I'm going to do it in a way that I tend to do these things in Reflex. The way it starts, of course, is if we go into our nav bar, you would go to see the nav bar link. I'm going to get rid of some of these that I'm not using. And of course, my home page, I wanted to go to slash, and then my about page, I wanted to go to about, just like that. So I can actually click on about, and it should be able to take me there. Home takes me home, and so on, right? And so the same concept would come through with all of these other links that you might have somewhere. You want to be able to actually run those links. There's another one though, and that is on a drop-down menu. Something like this, we need to actually navigate. And unfortunately, what we can't do is just say href like that. That actually does not work. So if we did href/about, and we came in and broke this down and clicked on about, it still doesn't navigate either place. So we need to actually make this a little bit different. And the way we're going to do this is by starting off and creating a new directory. I'm going to call this directory navigation. And then inside of here, we'll go ahead and create our init file. And then we'll go ahead and create our routes.py. Now I put constants in here for the routes, like home route, and this is equal to slash. And then about us route equaling to /about. Great. With this in mind, in my navigation, I'll go ahead and do from dot import routes, and then just go ahead and say all and routes. Now the reason I'm doing routes instead of each individual route itself is because I don't want to have to update the init every single time I add a new route, which could be many, many times. So what this means is I'm going to go ahead and use these navigation routes in multiple places. That's the key here. So in Reflex GPT, the main one, we already have 2 routes defined. Now I can bring in the navigation item, and we could do navigation.routes.home route. And then the same thing true being about. The nice thing about this is then it can propagate wherever we need these routes, like our navigation bar. So back into our UI, into our nav bar here, what we want to do is we're going to go ahead and do from Reflex GPT. We're going to import navigation, and then I'm going to go ahead and use those routes in here. So the home page, again, navigation.routes.homepage route or home route, and then the next one is going to be navigation and about us route. And of course, we could do this in the footer as well if we wanted to add in additional routes in here. Feel free to do that. Feel free to fill it out on your own. It's not something I'm actually going to do at this time, but it is something I would be aware of, and just having one single place for all of the different root routes. Not so much dynamic routes, but the base routes themselves. Dynamic ones would be something like you pass in ABC or 1, 2, 3. That would be a dynamic route. In this case, it's just about. Dynamic routes is something we'll talk about in a little bit more detail soon. But for now, this is it. This is the only sort of navigation I want to have at this point. But I do want to take it one step further, and I want to be able to actually use click events. So I want to be able to click on these and have it navigate. The way we do that is we have to introduce Reflex state. Now we're going to look at how to handle click events so we can do navigation that way. So inside of navigation here, we're going to go ahead and create state.py. This is going to be importing Reflex as Rx, and then we'll go ahead and do from dot import routes as well. And then we're going to go ahead and do class nav state, and there's going to be rx.state. The idea here is we want to have a handler for something like to home, and this is going to do return rx.redirect, and then this is going to be routes.home route. That's the idea, at least. So what we have here is a state element that can be used in a lot of places, but like when we have an on-click event. So what I'm going to do before I actually do the redirect is I'll just go ahead and print out, clicked, something along those lines. Cool. So now that we've got this, I'm going to go back into my init file here, and I'll go ahead and import the state as well. There we go. Now back into our nav bar, we still have navigation installed here or running. So now what we can do is we can go down into the drop-down menu that we had before. So this is it right here. I put those hrefs, those didn't work. So what we do instead is we can run on click, and then this would be navigation.state.navState.toHome, as in calling that function directly. Now I realize this is a little bit long, so perhaps you want to actually import the state element itself. But the idea here is we have an event called onClick. So this can happen with a touch or a mouse click, either one. Those are considered click events in the browser. So if we go into the browser here and we break this down, we can actually come in and click About or Home. And then back in Reflex, we can see that it says clicked. So those are quite literally the click events that are coming through. And so what we can do now is we can actually just redirect that to where we want it to go. So in this case, we can say to home, or we could do something more like to about us. And then we use that same route that we had before for about us route. And then we go ahead and bring that into our nav bar for the other one. And so there we go. Now we've got to home and to about. If we click on home, I'm already on home. If I go to about, notice that it does actually navigate to about with this click event. Now, the nice thing about click events is they can happen in other places. So let's go ahead and take a look at what that looks like by going into one of our pages. I'm going to go into my home page and say, let's do a little box here. We'll go ahead and do rx.box, and we'll go ahead and say go to about. That's it. That's going to be our box. So now what I'm going to do is from our GPT, I'll also import navigation, and then we'll go ahead and do on click, and this is navigation.routes. Or rather navigation.state.navState.toAboutUs. Okay, so now a click event in a completely random spot, I can click on it and there it goes. Now, this means that we can do other things with click events. That's the idea here. You don't only have to navigate, you can do a lot of other things like submitting a form, you can have buttons toggle, you can display things differently. So there's a lot of things that go on in terms of dynamicness with your application by using RxState. In this case, the dynamicness is really just a redirect. That's not really that dynamic. It's much like a link, but it is nice to know that we can use it anywhere we want to. Now, naturally, I actually don't want this on here, but the point is that we can use rx.state in a lot of different ways. And we'll see other ways on how to use it here soon. But overall, the idea being that we can actually do this redirect from any element, let alone a click element like this. Now, the reason you actually don't do elements like that on your standard nav bar is because this is quite literally a link. So if you actually right click on it or control click or command click, you can actually do copy here, and that will actually be the link itself. Or actually, wait, let's see, copy link address rather. That will actually be the link that it is. And this also means that you can open it up in a new tab, and you can do all of the normal things that you might be familiar with links. Whereas click events don't have that same element. If I right click on it here or control click on it here, it will not do that same element. That's one of the downsides, of course. And so when it comes to drop-down menus, one of the things you might be like, oh, can I turn this into a link? Unfortunately, there's not a simple way to just do that. There's probably a way to make a new component yourself. This, to me, is by far the simplest way to do it on drop-down menus where there aren't necessarily the actual href link itself. If you find a really good way to do it, please let us know. Otherwise, let's actually take a look at how we can use this state in a different context with a form. Let's start building out our chat page and component. The way this is going to happen is we're going to keep it all in one element in here. It's not really a static page, which is what About and Home are. It has other elements to it, so for that reason, I make it its own component, its own folder. And so I'm going to go ahead and bring an init file in here, and we're going to start with simply page.py. And what you might not be surprised of is we're going to go ahead and import reflex as rx, and then we're going to go ahead and do from reflex GPT, we're going to go ahead and import our UI, and then I'm going to go ahead and define our chat page, and this is going to return back UI.baseLayout of some sort of layout in here. Now, in my case, I'm going to go ahead and grab maybe just the heading layout, something like that. I'll go ahead and actually use the whole VStack like I have in my About Us page, because that will probably come in handy in a little bit. For now, I'll just go ahead and say chat here, something like that. With this in mind, I'll go ahead and do my imports. So from .page, we're going to import our chat page, and then we'll go ahead and do our all. And there we go, chat page. And then into my main configuration, we will now bring in chat, and then we'll go ahead and add in chat, and then chat page. Navigation is going to be our chat route, which of course I don't have yet. Let's go ahead and add it. And there we go. So this is actually more of like a chat base route, but we will leave it in as chat route for now. So now we should actually have our routes in here in terms of chat. So let's go ahead and jump over into just simply chat. Good, chat here is working. Now, of course, what I might want to do is in my main nav bar, maybe I want to add in chat to it. And so I'm going to go ahead and do that in two places, of course. So the first one being chat, and this should be to chat. Naturally, I need to actually create that in my nav state. Next up, we're going to go ahead and get rid of about. I don't need that on there anymore. I don't think I ever really needed it. Actually, we'll just leave it for reference purposes, but we'll go ahead and bring in chat here and chat route. Okay, great. So next up, of course, is our state. We're going to go ahead and grab this and define to chat self and return rx.redirect of routes.chat route. Great. So now, if I were to break this down, I should be able to navigate around with my click events as well as this. Great, so that's the start of the chat component. Now we need to look at a form. As soon as you want to create a form to take in data from a user, you often start with this state of the form, how to actually handle the submission event. Much like an onClick event, there's a onSubmit event. So inside of chat here, we're going to go ahead and create our state.py. And in this case, I'm going to go ahead and call this my class. And this is going to be our chat state, which is going to be rx.state. And of course, we're going to go ahead and import reflex as rx and not relfx. There we go. And what we want here is we're going to define something called handle submit. Okay. It's going to take in self and form data, which is going to be a dictionary. And we're going to take a look at that form data itself. We're going to start like this. Now, in the long run, we're probably going to have to update how this handle submit works, which we'll get into in a little bit. But for now, let's go ahead and actually create the form based off of this state. So now inside of chat, we'll go ahead and do our form.py. And once again, we're going to import reflex as rx. Now we'll go ahead and do from.state. We're going to import the chat state. This time, I just want to bring in the whole class itself because I'm probably not going to move it around that much. Next, we're going to go ahead and bring in our chat form. And once again, it's going to return back an rx.component. Basically, every component you want to use needs to return back an rx component. The component we're going to return back is simply rx.form. That's it. What we could do with this form is, of course, have inputs and all that, but we can also do an onSubmit event and do chat state.handleSubmit. You can also do something like reset onSubmit. For a moment, I'll leave it as false. So naturally, the next few things are going to be related to the form element itself. So what I'm going to do is rx.vstack. So I want to actually stack a few items on top of each other, or vertical stack. The items I want to stack are going to be rx.textArea. I'll leave that empty for a moment. And then rx.button. And the label we'll use is simply submit. And then we'll pass in a type of submit. So we could use a different input element than text area. And by all means, go to the Reflex docs and see all of the different components that you have available. We've got forms in here. We've got input. We've got radio group. Text area, of course, is what we're using. Here's that example that they have on there. Notice they also have the ability to do a heading. There's a lot of different things on how you could do this just by grabbing their stuff. look at the V stack here. We've got the button next to the text area, which is interesting. But overall, the idea is we have a text area and we want to declare it with a few things. The first thing is going to be our name. What element do we want this to be? There's going to be key value pairs that come into our state, form dictionary. This is going to be the key of that key value pair, as we'll see in a moment. We can add in a placeholder here and say something like your message. And then we can add in, let's say, with. And I'll go ahead and do 100%. There we go. And I'll also go ahead and say required being true. Now, you might notice I have a bunch of quotes and single quotes all over the place. That's because I don't have the auto formatting on, but you know, in VS Code, you should probably have the auto formatting on. But the idea here is now we've got our text area and our button. So how do we actually use this form? It's actually really, really easy. And maybe you already have a sense of how to do it. First off, we go into our page that we want to import it from. So this is going to be from.form, import the chat form. This threw me off a little bit, but let's go ahead and grab that chat form and I'm going to put it right underneath the heading itself. And then we're going to go ahead and take a look at our chat here element. Looks like we have a bit of an issue. Saving it and we'll go ahead and refresh once again. And there's our actual chat bot that is, or our chat message input that is coming through for our eventual chatbot. So I'll go ahead and say hello there, exclamation mark, hit submit. And notice that here is the message that comes through. This, of course, is coming from our form state. Here is our form data, right? So once again, I can submit it. And here's our form data. Now, what we have here is the form data is staying. So that goes back into the reset on submit being false. If I change it to being true, then we're going to have some cool stuff going on with it. And let's go ahead and run that again. And there we go. Right. And so there's the key value pairs in action as well. If we wanted to give this text area a different name like user input, you could do that. And then when we actually go into our chat and print things out, it will actually show us that new key based off of the name you give it in the text area, which of course in our case, we're going to go ahead and leave it in as message. Now, if you are unfamiliar with this process outside of using something like Reflex, doing all of this in this clean of a way is not trivial at all. But the cool thing is, this is only the beginning. We actually have another thing that's really, really cool, as in, how can we say that it was submitted? How do we actually take a look that the form was submitted in a dynamic way? Like maybe a message right next to submit that it was submitted. Now we're going to conditionally render a message when the form is submitted. The idea behind this, of course, is to say success, your form was submitted, but also if there's an error of some kind, we need to be able to handle when that state changes. So the way we do this, of course, is inside of our chat state. We're going to go ahead and declare a argument here as did submit. This, of course, is going to be a Boolean and the default will be false. So we'll leave it at this for just a moment to see generally how we can grab this data. So now into our form, what I want to do is right next to this button, I want to render text. The way I can put it right next to it is by using not vstack, but hstack. So I can go ahead and do rx.hstack. And then I can pass in the button as one of those components in here. So I can tab this over. And then right next to that, I'm going to go ahead and do rx.text and say success. Right? Now, as it stands right now, this is just going to render out success. I don't want it to always render. I want it to be conditional based off of something going on with the state. Now, to use conditions, we use rx.cond. And we're going to go ahead and use the condition we want to use. So I'm going to go ahead and do the fallback values, did not submit, and submitted, something like that. And then the first one is going to be the actual condition, which is going to be based off of the chat state, and we can do did submit. Okay, and so we've got did not submit in here because the default was false. If I go back in this state and change it to true, it's going to change to true. Cool. So we actually want to make this a little bit different, and instead of just using this regular Boolean value, we're going to do something called rx.var, because this is actually a variable. Right here is actually more close to a constant, but we want this to be a variable. So user did submit, and it's going to be self. It's going to return back a Boolean, and then we're going to go ahead and actually bring in the return self.did submit value in here. Okay, and so that's actually what we'll use as a condition. But the idea now is we actually want to change these conditional values. So in handle submit, all I need to do is change this value right here with self.did submit being true. That's it. Now if we go in here into our submit, notice it's on submitted, so let's change this to being false. Start off with false, and it should say did not submit. So I'll go ahead and say, here is my message, hit submit, submitted. Fantastic. Now, once again, this is not a trivial thing to do if you were doing it outside of Reflex. It would take JavaScript, HTML, some backend logic as well. There's a lot of different things that would have to happen, which happens in only a few lines in this one. Now, we do want to make this a little bit more dynamic. In one case, I actually don't need Rx text did not submit. So if I want just an empty value in here, I just put a fragment. You could probably put an empty string in there as well, or empty text. But in my case, I want a fragment in there. So I'll go ahead and say new, and we hit submit. Great. But there's one more thing that I want to do, and I want a timeout. I want to add dynamicness to this message. I want it to be up for like 3 seconds and then go away. In order to do that, we need to adjust things about our state and use some built-in synchronous capabilities that Python has with async IO. Let's take a look. Now we're going to take a look at two different ways to do something called a timeout. The idea being, of course, if I type out a message, hit submitted, I want this message to go away, this success message to go away. Now, this timeout method or this methodology can be used with many other things. You could think of it as like running some sort of background process right next to this message itself. So the first way we're going to do this is by using standard Python, which is just using the time module and doing something like time.sleep and then doing 3 seconds. So let's do 2 seconds, and then I'll go ahead and do self.did submit being false. So I'll go ahead and save that. This seems like it should work. If I run this and type it out, the message doesn't even show up anymore. So that's a problem. Now, the way we solve this is by actually just doing a yield here and turning it into essentially a generator where we can yield the different state changes right inside of the function. So after a little bit of time, it goes away. But what would actually be better is to use asynchronous Python or async IO, doing basically the exact same thing. So instead of time, we actually import async IO. So we're going to go ahead and do import async IO, and then we'll go ahead and use async IO.sleep. But of course, the only way to do this is we need to turn the function itself into an asynchronous function, and then we do await async IO sleep. And now if I type it out and run it, let's give it another shot, it will now do the exact same thing. Now, the reason you might want to use async IO is because this can do longer running tasks or a bunch of things that async IO does really, really well versus time.sleep. So realistically, you wouldn't be sleeping anything here. This is just to highlight activity that could be happening with like an API request of some kind, if you wanted to have an API request in there. I can highlight a bunch of other things in terms of background processing that you might end up doing with async IO. It's pretty neat. That's a simple way to do timeouts. Let's keep going. Now we're going to start the process of rendering out our users' messages as well as our chatbot's messages. Now initially the chatbot messages will just be an echoed version of the user message, but the user interface and all the logic will be there in Reflex before we actually implement the chatbot portion. So to do this, we're going to go ahead and create a new class called chatMessage, and this is going to be rx.base. And in here, what we can do is we can declare attributes we might want. Now, you can think of this as like a database entry, like a row itself. You could think of it in that way, but it's not really that because it will go away once we refresh the page. So it's more like state itself, but we can actually set some elements in here directly. So we'll go ahead and do message is a type of string, And then isBot is going to be a Boolean value, and we're going to go ahead and say false. So the idea then, of course, is down in our handle submit here, we're going to go ahead and create these elements. So the very first item is going to be related to our specific user. So going back into our form, we've got our handle submit here, and then we've got our message. So that's the data we're really looking for from this form data, right? So we can say that our user message is equal to form data.get of message. That's kind of the point. And so then we can say if user message, then we would run through this process, right? And so what we do then is we want to actually grab and create an instance of this message. So I'll go ahead and say chat message equals to that message, whatever it is. And then we're going to, of course, going to pass in our user message as the actual message for the chat. And then I will also explicitly say isBot being false. Okay. So then I'm going to go ahead and come in here, and after this sleep message here, I'm going to go ahead and give a chat message being isBot being true, right? Just denoting it different. This is more of like our response itself. Okay. So what we have here now is two different messages that we want to eventually render on our page. So that actually means that it's going to be very similar to this did submit, but it's going to be actually list of messages. So I'll go ahead and say messages, and this is going to be a list of type chat message, and the default is going to be empty. So we need to use this list message from typing. So we'll go ahead and do from typing. We're going to go ahead and import the list type so that we can actually have this as the correct data type itself. So now that we've got this, we can just go ahead and say, instead of saying chat message equals to, we can just do self.messages.append that chat message itself. And then we can do that same process down here with the bot. And once again, keeping it as true. Great. So with this in mind, I can actually maybe further improve this by saying something like append, and we'll call it append message, and we'll go self message and isBot, again a Boolean value being false. So this might be another way on how you want to go about doing it, where you just come in here and you have a completely separate message for this on how it ends up working. So if you wanted additional logic in here, you totally could have that. I'm going to go ahead and leave it in as append message, because then I can just come down here and just do self.append message, user message, and isBot being false. It's just cleaning it up a little bit. It's not that much of a difference, but I'm going to go ahead and keep it in like that. And there we go. Okay, so now that we have the ability to add in these messages to our chat state, it's time to actually take a look at how to loop through them, how to actually visualize them from our chat page itself. Now we're going to take a look at Rx for each for rendering out all of our different chat messages that come through. Now, once we understand how to do for each, then we will actually render out the message box itself. So what I want to do is I'm going to come in here and I'm going to define something called message box, and I'm going to give it my chat message as argument, which means I need to bring in that class. So we'll do from.state. We're going to bring in our chat message class here, so the data types are correct. And then all we're going to do is we're going to return rx.box and rx.text of the chat message.message. I'm not going to change anything else just yet. I'm just going to have this box. This is a very simple element that I want to render all of the messages, the list of messages, into my base layout here. So above my chat form, that's actually where I'm going to go ahead and do it. Now, the way this is going to work for me is I'm going to go ahead and come in and do another rx.box around these messages. And we will just go ahead and say rx.forEach. This is actually how you can do iteration. And of course, the iteration itself is going to be based off of our state, not our chat message itself, but rather the state element that's storing all of these values. So I'm going to go ahead and bring in that state itself. So we've got our chat state here. So now I can do chat state dot messages. So this is going to be the iteration. The first part is the iteration. The second part is the component that we will use to do the iteration, which of course is this message box right here. That's it. And so the actual rx.box, we are going to go ahead and bring in and say it's a width of 100%. Okay. Just so it's a little bit responsive is kind of the point. Now that we've got that, let's actually take a look at our app. Assuming everything is still running and rendered out, I'm going to go ahead and write some gibberish here, hit submit. There's that message. Over some time, I get another response back. So granted, the styling of it isn't great, but it's actually rendering out new messages, and then it's echoing that message back because it's basically the bot itself. So taking down this logic, the reason we have this chat message class as well has to do with this Boolean value right here. So we can actually use this Boolean value to render things out just slightly differently, right? So what I'm going to do is inside of the box itself, I'm going to go ahead and say the background, let's go ahead and do background color. And this is going to be equal to, we're going to go ahead and put a comma here. And we're going to use a conditional, which is rx.condition or CND. We can use a conditional value. Once again, the Boolean starts, and then you've got a component 1 and then component 2. So basically the true value component and then the false value component. So that's kind of how you should think of condition itself. So in this case, I want to actually implement something. So the chat message itself, I'm going to go ahead and come in here and use, instead of chat message, I'll use is bot, right? So that's going to be a true or false value, a Python true or false value. And then the true component itself is going to be rx.color. And in our case, if I actually type out rx.color inside of VS Code, I actually get a bunch of different color options in here. So the one I'm going to start with for a bot message is just going to be simply, we'll use gray. And then for the user message, we'll go ahead and come in here and say something like blue. Okay. So now if I go ahead and make sure that everything's compiling again, I can run my message and hit submit. Now I get my message in a background color of blue. And then the second one was also in blue. So let's go ahead and double check our state to make sure we did this correctly. So here's our state. We appended the message, and I see one little error that I should have updated in the last part, and that's this little bot right here. So now we've got a better format, hopefully. So if I type things out and hit submit, now it's going to go ahead and hopefully go back and forth with the colors. And sure enough, it does. Great. So we have different colors for each submission, which is super nice. But what we want to do is we want to style this a little bit differently. The way we're going to do this is by using Reflex Chat. This example, I just actually modified a little bit to still make it fairly straightforward and based off of what we're doing. So what I want to do then is change this message box slightly to actually have a few different styles in here that I'm just going to go ahead and copy and paste. And we'll talk about them in just a second. But we've got a message style. This will give us that sort of round box look and also make sure that it is aligned correctly. Back into the message box itself, it now has two boxes. Inside of that box, instead of rx.text, we are using Markdown, which means that our chat message could be Markdown, a Markdown component, which is going to be really nice for our bot. Then, of course, that background color is still very similar, just sort of change the colors just a little bit. And then the text color is also changed a little bit as well. That markdown element is what's going to be on the left or the right, according to the next part, which is this text align here, which will actually align that text as see fit. And then it gives us a little bit of a margin, and that's it. So I shouldn't actually have to change much here. And the only reason I copied and paste that is because it's fairly tedious to get that styling correct. And so it's easier to just look at something different. But now we see that we can go back and forth with our actual chatbot itself. Or at least it's getting towards that direction, which I think is also fairly nice. So one other thing that we might want to do is inside of the box itself, perhaps for the actual for loop, perhaps we want to actually add in, or rather I'll say the VStack, what we might want to add in here is a margin and doing something like 3 reams and auto. This will just give us a little bit more of a margin on top and bottom so it doesn't actually interact with other elements when you start typing a lot. Instead, it just pushes them further and further down, and then you just kind of scroll down with it like that. Now it's time to actually do the bot portion of our chatbot. Of course, that's bringing in GPT into the Reflex GPT project. Now, the first thing that I actually want to do is I want to reformat what I'm going to be sending to our API service that will be the bot itself. So that means that inside of the actual state message, the chat message here, underneath append messages, I'm going to do something called get GPT messages. And the reason for this is that we want a different format for the messages for our end-up model, the model that we end up using. So the format that we're going to be using is going to be based off of OpenAI's GPT format, which we'll see in just a moment. But this function right here most likely will change depending on the API service you end up using. So we'll talk about that more in just a moment. But for now, what I want to do is we'll say GPT messages is equal to an empty list. Then we're going to go ahead and do for chat message in self.messages. Then we're going to go ahead and grab what the role will be. So user is the default role. If the chat message.is bot, then the role is going to be system, as in these are going to be the responses back from the system itself. Then we'll just go ahead and do our GPT messages.append, and it's going to append a dictionary of the role, whatever the role ends up being, and then the message being the chat message.message, whatever's stored in our state for this chat message that we've seen throughout. Okay, so now that we've got that, we're going to go ahead and return back those chat messages. And so now what I can do in here is after I append my message, I will still yield that back, but now we'll go ahead and say our GPT messages are equal to self.getGPT messages of our messages, right? So I actually don't need to put anything else in there because it's going to grab all of those messages. So those are going to be the default messages. That's going to be the list itself. Now, one of the things we might want to consider in here is the initial prompt. So the initial prompt would be something like role and system. And then we'll go ahead and say message, and you are an expert at creating recipes like an elite chef. Respond in Markdown. We'll come back to that in a moment. Great. There we go. So there's my prompt. Now, this is where prompt engineering comes in, and we can talk about all sorts of things related to that, but that's the initial prompt. Every message that comes after that is going to basically kind of bundle up to this prompt. Great. So now we need to actually build out the way to handle those messages. So I'm going to do this inside of an AI module. I'll call it AI.py. This is where I'm going to put it. Now, before I go much further, I will say something like LangChain would be really good here. Using LangChain in lieu of what we're going to end up doing might be something that you consider because it's optimized for a bunch of different LLMs or large language models, as well as many other things in there. Using LangChain is outside the scope of what we're doing here, so feel free to check out my Try LangChain video, whether it's on YouTube or on my website under courses. You will be able to learn a little bit more about the fundamentals of LangChain to make this next process a little bit more straightforward. Now we're going to be using OpenAI's API service to actually do the bot side of things. That's what we've already designed for right now. You could always use something like Anthropic as well. I think Claude is great. OpenAI is great. Llama, the open source model, Llama 2, that's also great. So there's a lot of different options that you have in terms of the bot itself. The reason we're going to be using the OpenAI bot is because it's fairly straightforward to get going and it's incredibly reliable at this point. So the other side of this is we are going to deploy this application using a managed AI service or a managed LLM is something we want to do at this point. Because once you deploy this, using a model locally is just not going to work like an open source model, whether it's using Ollama to run Llama 2 or any other open source that runs locally. Nevertheless, now that we have that out of the way, let's go ahead and sign up for OpenAI. And you're going to want to do the API login. You're going to select the API, not ChatGPT. Once you do that, you'll see something like this. You might need to create a project and make all that working, but the idea is we're going to be implementing this right here. And so we could go ahead and copy this for now and go into our AI.py here. Now, the actual LangChain, if you went that route, would basically replace what we're doing here, but you can still use OpenAI and you can still use it in a very similar way that we're about to use it. So the next thing is what I want to do is I want to decide what model I'm going to use. So I'm going to go ahead and declare it as a constant. So we'll do our OpenAI model and set it to whatever we'd like. Now the default is the state-of-the-art model of GPT-4o. We might want a different one. So in this case, we go into the documentation of OpenAI and look at the different models that are there. And in this case, I'm going to go ahead and use the 4o mini. This is the one that's recommended for very low cost but rapid responses. So that's going to be the model I'll use. Okay, so we'll go ahead and paste that in here. And I want to turn these actually into different functions. So the first one is going to be get client. And this is going to just return back a initializing of OpenAI. The next one is going to be something like our get LLM response. That's what I'll call it, just to make it a little bit more generic. And so that response is going to be related to this, of course. Naturally, I need to initialize the client again. So I use that function for it. Then I get this completion in here. And so the completion itself has a lot of different things that are attached to it. But just to make things simple, we can do completion.choices of 0 and then .message and then .content. That's how you can get the actual system response back from before. So the next thing, of course, is actually passing in the messages that we had. In our case, we'll call these our GPT messages. What do you know? Now I'm going to go ahead and replace that right there. And this is almost complete, but it's not quite there because we need to have an OpenAI API key. We definitely need to have that. Now, on one hand, you could inject it inside of your environment, as in os.environ. So like if we were to come in to our Z shell or any sort of shell and just run echo $, that value, you might see something like this. In my case, I actually have one there, although that's not a valid one any longer. So you could feel free to ignore that one. I actually want to have mine right in here. And so for this reason, I want OpenAI and Python decoupled in my system itself. So I'm going to go ahead and run pip install-r requirements.txt, and that will actually install all of the requirements I need. Python decouple will be used to actually bring in our API key from somewhere else. So we'll go ahead and do from decouple. We're going to import config. And so I'm going to use config for the OpenAI key. And I'll set the default being none. And then I'll also pass this API key into OpenAI here. And it'll be API key of that OpenAI API key. So this is actually why I use Python decouple, is because I can set a default. I can also cast it as a different value. So if you need a Boolean or something like that, you can use 1 or 0 and it'll be a Boolean value. But also, if I actually don't set it, I can leave the default being off, and this actually runs an error in my application, which would probably be something I'd want for my OpenAI key with a chatbot. But the idea now is we just go into the root of our project, and we're going to go ahead and create a .env file, and we're going to go ahead and pass in our OpenAI key here. Now, the way I'm actually going to end up using this is by going back into OpenAI, going into the dashboard, grabbing the API keys. This location has changed a few times, so do keep that in mind. Then I'm going to go ahead and create a new one. This is going to just be called Reflex GPT. Now, in production, you're probably going to want to restrict this. You probably don't want to have everything in here. But since we're just learning and stuff like that, I'm just going to leave it in as all permissions. And then I'll go ahead and create a new secret and complete the puzzle that pops up. Once you do that, you will get your API key. You can go ahead and copy that and bring it into .env. So this is yet another reason as to why I use Python decouple, is because it will load these .env files for you. There are other ways to do it, but it takes place of os.environ.git or whatever you might end up using for loading environment variables. Feel free to use other ones if you want to. I think Python decouple is one of the best ones out there. So now that we've got this in place, we have a way to actually get a response. So going back into our state itself, we're going to go ahead and do from .import AI. Now I'll go ahead and use this from my GPT messages right here. So the actual bot response is going to be AI dot and get LLM response of our GPT messages, which of course, again, still has our prompt in there. Now I can actually get rid of this async IO sleep. I don't need that anymore. The did submit being false is fine. We can actually remove that and more think of this in terms of is processing or is loading, but I'll leave it in as did submit. So now that we've got that, I actually don't need the async.io import anymore. And so I'm going to go ahead and make sure that everything's compiled and is running. So now we can go ahead and test out our GPT. So going back into our chat here, I'm going to go ahead and say, hey, give me a recipe for good tacos and hit submit. And we get an invalid value here. So maybe there's something wrong with our content itself. So let's go ahead and go back into our chat messages themselves. And so we've got our choices, our GPT messages. Let's go ahead and make sure that we've got actual messages coming through from that. So let's go ahead and print that out. And let's see what's going on. So we've got unexpected value for content. And, oh, this might be the issue. I think this is no longer message. Let's go back into OpenAI's docs here. So into our docs, this has changed a little bit. It should be content, not messages. So this should say content, and this should also say content. Maybe Claude does it and I just got it mixed up, but overall, we now have a little bit different of a look here. So I probably don't even need to print those things out, but let's go ahead and try this again and say, give me recipes for a good taco for 10 people. Hit submit, and here we go. So it is definitely loading. So this submitted should probably say loading of some kind, and eventually I get a response back. And what do you know? It responded back in Markdown, and here are all of the instructions that we can go. Great. How about chicken and pork too, or something like that, which I don't actually know what it gave us. But the idea here is it's going to give us this response, and then it's going to come back, filling from that response itself. There's the response itself, and then eventually it will actually show up in here as well. Let's just make sure that it is yielding everything, and sure enough it is. And there we go, chicken and pork taco recipe, and there it is. Great. So there would be a way to do streaming responses, and I actually think Reflex Chat in here has a way to show you how to do those streaming responses as well. So basically you can see it typing, and it all will render in the Reflex instead of just waiting for it to just show up, as you might expect. This is a very detailed response. I think it's okay. I don't actually know. I'm not going to go through the process of figuring it out. But it does have a lot of food in here, and this probably would fit about 10 people. I think that's what I said. 10 people? Yeah. Cool. So that's it. We now have a chatbot. But the thing is, what happens if I want to, update something, or I want to go ahead and get rid of this? Of course, all of that chat goes away. So now I have to do it all over again. So the next key thing of this is actually storing those responses so that we can retrieve them at any time, so that there are our own chat messages. Again, not too dissimilar from a lot of the LLMs that you might work with, but of course this is ours, so we want to see how it's done. Let's take a look. Now we're going to configure Reflex to work with Neon. Now, of course, Neon is a Postgres database, so it's really connecting Reflex to Postgres. But a big part of the reason that we use Neon is, one, I partnered with him on this series, but two, it's Postgres but serverless. So that is, if you're not using it, it's not going to be charging you anything. As soon as you start using it, that's when you get charged. In other words, very efficient. Now, for a lot of you, this might be free for a long time. So feel free to jump into neon.tech/CFE, sign up for your account, and we're going to go through this process. So once you actually go in, you will log into your account and you'll see something similar to this. Now, you might only have one project because you're on a free account. In my case, I have a basic account. But the idea here is we're going to go ahead and create a new one, and we're just going to call this Reflex GPT. Postgres 16 makes sense. Region is where you're going to want to deploy this application. So wherever you end up deploying it is where your region is going to be. Now, in the short run, it doesn't matter that much because you can always delete it and then just spin a new one back up because it's really easy to do so, as we'll see in just a moment. Oregon's actually near me, so I'm going to go ahead and use Oregon as the database I'll end up using, and we'll probably deploy it in that general area as well. So now that the project is ready, like 2 seconds later, we're going to go ahead and grab something related to it. So going into the dashboard, you can see this connection string here. We're going to grab this connection string. I'm going to go ahead and copy this snippet, and I'm going to go ahead and bring it into my .env here, and I'm going to call this my database URL. Now, the reason I call it a database URL is that's typically what you'll see in Python projects, is it will be called database URL. Now, of course, you could also have all of these things broken up. As you can see, in the Neon console, you can see other ways on how you can connect this. So like SQL Alchemy is basically what we're using right now. And notice that it even shows you how to create a connection string and then connect an engine. So this is a connection string. That's exactly what it is. So we don't really need to do that for two reasons. One, it's very common to have a connection string in Python projects. Two, Reflex has support for connection strings. So in rx config.py, this is actually where we're going to go ahead and use this item. So what I want to do here is I want to go ahead and say from decouple, we're going to import our config, and then we're going to go ahead and do our database URL, the config of that database URL. Now, unlike the OpenAI key, we actually want to make sure that this is always in there. And so I'm going to leave it as is. And then the argument that you pass in is just simply DB URL, which you can actually see in the documentation, database URL right there. Great. So with Postgres databases and Python, you need to add in one other requirement, and that's sci cop g, and I'm going to be using 2-binary. Now 3 is actually out and 3 is without the 2, which is interesting, but it's 2 because that's the default that you need for Reflex. That's why I'm using it as 2. But of course, this is just so that your Python project can connect to your Postgres database. That's it. It doesn't really do a whole lot beyond that. Maybe there's something I'm not aware of, but it's mainly the bindings so that your Python can connect to Postgres natively. Okay, so with this in mind, I'm going to go ahead and do pip install-r requirements.txt. Now, the reason I actually mentioned that has to do with the fact that if you need to use a newer version, assuming it's supported all across the board, then you'll be able to really easily. You just switch it to that new version, and you shouldn't have any real issues for it. Okay, so now that we've got this, we've got our database URL in here. All I want to see is if my application is still running. So I'm going to go ahead and refresh it, restart it up, because I want to make sure that Reflex can restart it. And of course, I did change the configuration altogether. So I want to make sure that, yeah, it actually does still load. Looks like it is. So loading 1, 2, 3, exclamation mark, hit submit. And it looks like that is it. Cool. Okay, so now that we've got this, what I want to do is I want to start the process of creating database tables in Neon that we can actually use for our Reflex chats, right? So these chats, we actually want to store the chat itself, the entire session, but we also want to store all of the messages that are coming through. So that's what we want to start doing right now. Now we're going to start defining our database tables, our database structure, which have column names and column types. That's essentially all we're going to be doing here. Now the reason we have column types has to do with efficiently storing data. So if it's a number, you store it as a number. You don't store it as a string. If it's a date object, you store it as a date object. You don't store it as a string. And then the same with the Boolean and all that. That's kind of the idea here. So what we want to do is define our first model. This model itself is going to be right next to another model or another table. Now, the logic behind this is fairly straightforward, and we've already have hopefully a good sense of it, and it has to do with the chat. When you create a new chat, that is going to be a new chat session. That's going to be in one table. The chat session will be in one table. Then all of the messages for all of the sessions will be in a separate table while referencing the original table, referencing that original chat session with an ID of some kind, which we'll see in just a moment. Now, I will say before we jump into this, Reflex has a lot of documentation that makes it super easy to get started with these tables. But of course, sometimes you might need to go a little bit more advanced, in which case you'll be using SQLModel, which Reflex is built on top of, which is also built on top of SQL Alchemy, which has Pydantic and all sorts of really cool things into it if you really want to get into the weeds of all that. I'm going to try to make it as straightforward as possible on how we're going to design these tables. Just keep in mind that as you see here, this is not a whole lot different than what we did with our chat message. This, of course, is by design. A lot of these things are meant to reflect or be similar to each other so that you're not having too much confusion when you start to use all of them. Even if it might feel confusing at first, once you get really used to using them, it's not confusing at all. Especially those of you who are from Django, you might not be familiar with this process at all. But the idea here is we want to create our first model file. So inside of Reflex GPT, we're going to go ahead and do models.py. All of our database models are going to be living in here. If your project grows into massive complexity, you might want to break these models apart into subcomponents. That's outside the scope of what we're doing here, but that's just the general idea that you might want to work towards. This is how Reflex recommends you do it, is just putting it into one single model file. It's a lot easier to manage those database tables that way. So what we see in the Reflex docs under Learn and down into Database Overview, you see the basics of an actual database table. So you first off import Reflex as Rx, and then you create your table. Now this is not a relevant table to us at this time. Now of course, if you want to see how to do user data and all of that, definitely check it out on my website under courses. There's a whole one called Full Stack Python. Check out that one. That actually goes into it in a lot more detail than what we're doing here for Reflex and for users. It does cover a lot of these same things with the database tables too, but then you'll get extra practice with it and you'll know it a lot better. So the idea here though is not user. We're going to go ahead and call it just simply chat, as in like our chat session. That's it. So what we could do is we could declare an ID here, but this actually comes by default inside of Reflex's rx.model, which you can even check in the model itself. Here is that default field, that ID field. This is a primary key. So all primary keys allow us to do is have a unique key or a unique number for each row in the database. So every time you add a new item in there, it gets its new ID. And in this case, it auto increments. It will automatically add one for you. You don't have to do it. The best databases do that by default. Okay, so that's one thing. The next thing is going to be our messages. Now, I actually don't want to store the messages directly in this chat, so we'll have to come back to that one. What I will put in is something like the created at, a actual timestamp of a date time object. So I'm going to go ahead and import that. So we'll go ahead and do from datetime import datetime. So I actually want to store when this chat session was created. The way we do this is by using a field from SQLModel. So we're going to go ahead and start off with that. So we'll go ahead and do from SQLModel, and we're going to import a field. Okay, so we got a field in here, and we want to declare several things about this field. The main one, the most important one, is the SA type. Now, the SA type stands for SQL Alchemy type. So SQL Alchemy type means that we need to bring in SQL Alchemy as well. So SQL Alchemy in here as well. Both of these things we don't need to actually install. They're already in there because of Reflex. Reflex uses these by default. So the data type that we want is SQL Alchemy dot date time. And then we'll go ahead and bring in our time zone being true as well. So that is going to be the column type. Notice that in Python, we have it as a datetime object. That means that when I do create this, I will be able to see this field as a datetime object. It's not going to be a string. So I can do like .date or .now, something like that, to see exactly what this datetime object ends up being. But in the database, it's stored a little bit differently, which is why we had to declare it like that. So the next thing is we actually want to do something called a default factory. As in, we want to actually create now when it is created. I want that to automatically happen as well. Much like the ID, I want to create a timestamp right now. Now, the way we're going to do that is by creating a function called, we'll define it as get UTC now, and it's going to return a date time object once again. So we're going to go ahead and return datetime.now. And in this case, I actually need to bring in the time zone as well. So I'll go ahead and bring in time zone here. And then we'll go ahead and use timezone.utc. Okay, so this is the factory. This is the function that I want to use whenever this field is created. And so it's going to be of this data type, and then it's going to automatically use whatever I have here for that function. So one other thing that we want to bring in here that I'll just go ahead and copy and paste is the server default. So SQL Alchemy has another ability that can allow it to do now as well on the server side. So there's two different ways on how to do it. The default factory takes into the time zone where the database side may or may not. But at the very least, we can actually change this on the fly, and that's what will end up being used as well. Okay, so next up, we're going to go ahead and say nullable being false, as in this cannot be a null value. It cannot be empty. So if for some reason you try to set it to being empty, it won't allow for that to happen. It will run an actual error itself. Great. So now that we've got this, I'm going to do one more thing, which is very similar to this, which will be updated. So we'll call this updated at. Now this one is just common. Whenever you have a timestamp as in created, you often have an updated one as in when it was changed. And the only difference between these two is we add in one more column here, and that's on update. We use this same SQL alchemy function of now, and that will store the saved value every single time the actual row is saved as well. Okay, so absolutely the basics of models. Even if it feels advanced, using a timestamp is very, very common. But the thing is, you could also do something like title, and you can declare it as a string. If you did that itself, then of course this is required. Very similar to like what we saw with our actual chat in the state here. This is required. This is a required thing. So if you came down here and tried to create a chat message without that being added, it's going to run an error. So same idea here. This is coming from Pydantic. It's a really nice way to make that happen. And of course, you could use fill to do all sorts of defaults in there as well. I'm actually not going to add that in. This right here is probably by far the easiest way to use a model. But this right here is a lot more practical and useful for what it is that we're trying to do, especially when it comes to ordering these things out. But now that we have this chat model, we want to go one step further and actually turn this into a database entry. So put it into the database. Let's go ahead and see how we do that now. At this point, all we have is a Python class with the potential to be a database model itself. It's not there yet because we haven't run our migrations. So to help illustrate how migrations work and how to insert data into the database, I will actually bring in the title here. This will not be here in the long run, but it will be here right now so we can see how to make changes to tables when we need to make them happen. Now, database tables, especially SQL tables, are structured, so structured query language for a reason. If we need to change the structure by changing the columns or the column types or the column names, we need to run migrations to make that happen. Now, we haven't done migrations yet because we, need to see how it's done, but also understand that anytime you need to make changes, even if it's going from 0 to 1, you need to run migrations. So that's what we need to do. Okay, so the process for this is fairly straightforward inside of Reflex. I'm going to open up a new terminal window here so you can see it a little bit better. And we run reflex -help. What we can see inside of this command, of course, is all of the other commands that Reflex has at this time. We see that there's one for DB. So I run reflex db -help. And once again, I will see a few other things in here. Init is the very first thing that we need to run because we haven't done it yet. We should only need to run this one time. Next, we'll run make migrations and then finally migrate. So let's go ahead and do that. Reflex db init. This will connect Reflex to the database, or at least start that process, making sure that some of the things about it are correct. So I'm not sure if there will be errors here if there are things that are incorrect, but I'm pretty sure the next two will. So if we do reflex db make migrations, what this is doing is it's preparing some files for us that are going to eventually change the database. The nice thing about this is it actually does create this Alembic folder here. Inside of this folder, we have some data about what's going on with our current project, right? So we've got in here, there's our data. We've got a few things related to it. Pretty cool. Now, in this case, I actually didn't see any database tables going on. So if I do db.migrate, this actually might not change anything because our database tables just aren't imported into our project anywhere. So I actually want to import them into our project. So inside of our chat here, I'm going to go ahead and do some of the basics for it, just to import it into our application so that it's actually registered by Reflex as a model that we want to use. So inside of our chat state here, I'm going to go ahead and define a new state, and we're going to define this as on load, and it's going to take in self, and then we'll just go ahead and do with rx.session as session. Then we're going to go ahead and let's bring in our model here. So I'll go ahead and do from reflex GPT.models. We're going to go ahead and import our chat model. Okay, so here we go. I'm going to bring that in right here. So what I don't want to do is get too down in the weeds of actually doing this on load, actually loading up the data itself. But we can see inside of the documentation under queries, right? So I'm under queries here. we can see this is actually how you can run these various sessions. So that's how we can run all of the different users for that name. There's other more general ones that you might run, but I'm going to go ahead and run the self.users here. Very similar to that at least. And for now, I'll just go ahead and say, we'll just run the session itself and do results equals to that. And it's going to be chat.select. I actually don't need this where clause, but I do want all there. And then I'll go ahead and print out what that ends up being once we get into it. At this point, this won't be used for a little bit. So we might still come back to it to make it a little bit better. But for now that I actually imported that model and actually start using it, I go to ReflexDB make migrations again. Now it actually makes something for me. So if I go back into that Alembic folder, I can see here is a model. So notice that it's importing a bunch of stuff by default. It's talking about what's happening with the model itself. But then finally, it's showing us that we are upgrading or making changes to our database itself, directly to our database. And here's all of those changes. All of this gets turned into SQL when we run migrate, otherwise known as the very next command. So this migrate command will then actually make changes to our database, assuming that we did everything correct. And of course, we can verify this as well. So if we jump into Neon and we go into our actual tables in here, we should actually see, well, two tables now. We've got a chat table with no rows. Notice that we've got ID, title, created at, and updated at. What do you know? ID, title, created at, updated at. And then, of course, back into the model definition itself, we've got title, created, updated. ID came in by default. Great. Then also in the Alembic versions, what we've gotten here is we've got this revision in here. If we go in there, 8D2, 8D2. What do you know? The same. So it is referenced in the database as well that this change already happened. The reason it's referenced is so that it doesn't happen again. We don't need to attempt to do this over and over again. In other words, if I run migrate again, it's not going to rerun that same thing. And if I run make migrations again, it's also not going to rerun that same thing like this, right? So if I run that, it's not going to go ahead and create this or anything like that. So the nice thing about separating these two is that now with version control, we can actually track all of these migrations. We can track what ends up happening with them. Now, one of the things about this though is that, if you are using different databases in different environments, as in you don't have a Postgres database locally or a Postgres database in production, but you use maybe like SQLite in one and Postgres in the other, you might run into issues with your migrations tables. So do keep that in mind, that when you're locally running things, you want to make sure that you're using the same database that you're using in production. You don't have to use a managed database service locally or even in production. But the idea is if you wanted to make sure that you have Postgres in both places if you're going to use Postgres, or you have SQLite in both places if you're going to use SQLite. That's really important. Otherwise, these migrations will likely fail, especially with my experience with SQL Alchemy and Alembic. That ends up happening more there than something like Django. It doesn't happen as much in Django. I don't know why. Maybe somebody else does. But now we see how we can actually sync up our Python code with our database tables. So what we want to do is actually insert some data here that's not a whole lot different than what we've got. Now we're going to take a look at how we can save data into our database. The functionality is called insert, but the idea, of course, is taking a line of data, some amount of data, and then inserting it into the database. We're not updating anything. We're just appending to what's already in the database. Now, the nice thing for us is this is already well documented on Reflex under queries. You see this add user thing here, and then all we need to do is run this Reflex state here with the session and all that. So let's take a look at what I want to do with that. And that is simply append message. So append message is quite literally taking the message and then adding it into our user interface. Now, before we actually add it into our user interface, we could also just add it into our database. We could do it before, we could do it after. I like the idea of doing it before so that if there were errors, then we could render those things out as well. Now, at this time, I'm not going to handle the error case just yet, but I will handle inserting this data into the database. So, of course, we've got our session here. Then we're going to run session add. Then, of course, it's going to be our database class, the database model itself. Then we're going to go ahead and commit it. So this is like preparing the database. This is like, hey, it's ready. Go ahead and put it in. Very similar to make migrations and migrate. Prepare, save. That's it. Okay, so how we do this, of course, is we grab our chat class, our chat model class, and then we come down in here and we do chat. So we initialize a chat object itself. This chat object does not have to be here. You could put it like that as well. Like that's totally okay. Now, the arguments that I have in here are not correct though, right? So I'm not using username and I'm not using email. What are the things I'm using? Well, of course, message. In my model, I don't have a message. I just have title. So I'll go ahead and put title. We'll say title and message. I don't need self. I don't need any of that. I can just go ahead and do that right there. I'm obviously going to change all these things to being correct because we haven't talked about related models just yet. But now I have a simple way to insert every single message that comes through. Now, of course, if it is a bot, maybe we don't want to save the bot message, or maybe we only want to save the bot message. That'll be up to you on how you design it. So if it is a bot, we can say if not is bot, right? Then we can run that same session. We can run that same call because, of course, it is still Python. So that controls that flow, and then we still get that message coming through. Let's go ahead and make sure that this is still running, and we can actually give this a good shot. So going back into our project, we will go into our chat here, and I'll go ahead and say hello world, exclamation mark, hit submit. All of the other things about the chat should still work. But something new that's working is if we go into our Neon database, into our chat table, what do you know? There's hello world. Now, this is not the correct message. This should actually be the chat message model that we'll end up using as well. So the idea of calling this chat is not ideal to me. I want to call it actually as chat model. The reason so it's not confused with chat message. So all across the board, I'm going to actually update it to chat model because very soon we will have a chat message model. This, of course, is not that. Okay. So once again, we can run it again and we can run some more messages or more data. Let's go ahead and do that. More data, exclamation mark, hit submit. And, sure enough, if I refresh in here, more data. Great. Fantastic. Now, before we actually do something called related fields, that is how we're going to go ahead and do another table for all of our chat message models, we are actually going to go ahead and see how we can get rid of a field itself with migrations. So in the very near term, what I'm going to do is I'm actually going to create a new model. This is going to be called my chat message, and I will actually call it chat message model for a good reason. And it's going to be rx.model and table being true. And then we'll go ahead and set that up here shortly. So that's actually where I want to store all of my chat messages. This is going to be a related field, a related table to another table. So they're going to be connected in a way. We'll see that very soon. But since I'm going to be doing that, I actually don't want my main chat here to have a title field anymore. So I'm just going to go ahead and comment this out. Now, keep in mind, as soon as I do this, you are preparing your Python application to delete this entire column, which means that all of the data that's currently in that column is going to be gone. That may or may not be a big deal. Now, of course, you could always download this data right now inside of Neon if you wanted to back it up. There's a bunch of other different ways on how you could back it up as well. One of the other options that you might want to consider doing before running your migrations is going in here and creating a new branch. So let's say, for instance, this is going to be my dev branch. I'm going to call it dev. It's going based off of the main branch. I hit create new branch, and here we go. So now I've got a new connection string. I'm going to go ahead and copy this, and I'll bring this into my env file here. So I'll comment out the database URL, and I'll put in database URL with this new one. Actually, I'll call this something like database URL prod. Now, what you'll see here is we've got our Postgres database. These are different strings here. One is for the dev branch. The other one is for the main branch. Now, the nice thing about this is you can see what actually happens when you change something like that. So let's go ahead and take a look. I'm actually in the dev branch, as you can see. I can go in the main branch. I can go in the dev branch. I can go back and forth on them. And I can go ahead and take a look at the tables. The tables are the same, regardless of what branch you're on, right? So you got the main branch, you got the dev branch. This is something that Neon has pioneered, these branching thing with the database. It's not usually this easy. So what we've got here is a new table that I want to see what it looks like with it gone. So before I actually commit this into Git or something like that, I'm going to go ahead and run my migrations. We'll go ahead and do reflex and run make migrations. Reflex db make migrations. There we go. And so this is preparing to make those changes. Now, what we could do is we can review these changes. So we could commit this into Git and we can review them. And we can see that, oh, it's dropping a table. It's dropping a column called title in the table chat. Interesting. Maybe I want to do that. Maybe not. I'm going to go ahead and do it. And I'm going to go ahead and run migrate. Okay. So it's running migrate, as in it's going to drop that table. That data is now completely gone. I go into my dev here, and what I see is it's gone. But if I go into my main branch, guess what? It is still there. So before you fully commit to being, oh yeah, I'm going to get rid of that table in production, this is really, really nice. So if you decided to change your mind, what you could do, of course, is git reset -- hard. That resets the original model itself. I can delete this migration. Let's go ahead and delete it. I can go ahead and delete this branch as well. Right, so going into my branches, my dev branch here, let's go ahead and delete that one, permanently delete it, and then I'll go back into my .env here, and I'll use this one no more. I'll get rid of it, and then I'll change this one to being database URL. Once again, we'll save that, and I think at this point, we should have that original database URL running. So let's go ahead and open this back up. I want to run this and go ABC123, hit submit. That should actually save something for us. But in this case, I might need to actually update my running because of the env. The environment variables changing like that sometimes causes a little bit of an issue. So reflex run once again, just to make sure that that issue goes away. And so that I can redo the chat. Now, what I just did is something you won't do very often, probably, where you're like, going to test one single column that you want to delete and all that. But it is really nice that it's there. So let's go ahead and try it again and hit submit. This time it should actually store it. We don't get any errors this time. I didn't even have to look at the error. I already knew it was something with the environment variables. But now I can actually go into my main branch here. I can go into the table and I can see that try again is in there, or, give me something good, ! Save that. And then, of course, that will come in there as well. So let's go ahead and refresh in there, and there we go. Cool. So super nice that we can do all of that. But of course, I actually don't want that field. I just wanted to show you all of the options you could do before you finally make that decision to get rid of that field. So I'm going to go ahead and run that with the reflex, and I'll actually run it in a new cell here. So reflex db, make migrations, and then, of course, reflex db and migrate. Great. Okay, so with these in mind, of course, I will need to update my state variable. So for now, I will actually comment this out until it's done correctly, so I don't actually accidentally make errors with that chat itself. It's pretty cool. Let's keep going. Now we're going to talk about relationships, as in related data from one table to another. It's actually fairly straightforward, and once again, it's well documented in Reflex itself on how you can do relations. But the idea is fairly straightforward. Every time we want to create a new chat that has like a different theme or topic, we want to be able to have a new chat session. So the way I actually named the model at this point is probably not great. I actually should call it chat session. So let's go ahead and do that. We'll call it chat session, and then we'll run reflex, and we'll have to do db make migrations. And we'll have to see if this does anything to us. And it does in a way because the import's incorrect. So let's go back into our state and call this chat session because that's the name of the model now. So let's go ahead and try it again. And let's go ahead and see if this does run any migrations for us. So let's go ahead and take a look inside of migrations here. What we've got is create table and drop table. So I didn't actually rename the table at all. I quite literally dropped it. So it's going to delete everything that we already had, which I think is totally fine, especially as we're learning. The idea here is, in the long run, you will think out these models well in advance. You won't be doing that many migrations unless, of course, you are just in development mode and you're trying to figure it out. Once you actually have these things pretty dialed, you won't need to do those migrations very often. And realistically, you'll probably name them better up front. But the point here is seeing how this all works. Okay, so we run reflexdb and migrate. Once that's all done, I'm totally okay with it deleting everything. In fact, I could create a brand new database in Neon at any time at this point because it doesn't matter because there's no real data in there just yet. Okay, so now we've got this idea of a chat session. So the chat session, we will create a brand new one for every sort of topic that we're after. And so the next part of this is going to be basically like the chat session, but this is going to be a chat session message or something along those lines. Now, I don't love calling it chat session message. I would probably actually more realistically call it message itself because that's essentially what's going on. But I'm going to leave it in as chat session message just so that it's not confusing at all in our state because we have this chat message here. We've got chat all over the place. So actually, I'll call it chat session message model. Again, this is a little bit beyond what I'd call it. I would either do message or message model. But again, we're going to keep it just like this. Okay, so now we might want to keep created at and updated at, but I don't think I'll need to update these very often because basically it's once a message happens, it's done. It's not really going to be updated. So I'm going to get rid of that. I will keep the timestamp though, the created at, because that's unlikely to change. The next thing is what values do I actually want to store in here? Now, on one hand, if we go into our state, you might want to store message and isBot. On the other hand, you might want to store your GPT messages, as in role and content. I actually like this a little bit better so we can actually store more realistic data to what we're putting into the actual AI system that we're using. So it's kind of up to you on how you want to go about doing it, but I'm going to leave it like role. So we'll go ahead and come in here and say role, and then we'll go ahead and use our actual message, which I believe, have it as content. Let's just double check, content. Okay, and there we go. So that is almost the field done, almost the entire model done, but it's still missing something major, and that's going to be our session. So we have our chat session up here. I want it to be also tied in down here. So I'm going to go ahead and say session equals to, well, it's going to go ahead and be a field itself. The default is none. The foreign key is going to be equal to the chat session.id. Now, realistically, it's not the capital chat session. It's going to be lowercase chat session or the actual model name itself, which you could verify in a lot of different ways. But one of the ways you could do it is by going into Neon and actually taking a look at the database itself. Let's refresh here. And so you can see that it is chat session all lowercase rather. That's usually what it's going to end up being, is all lowercase, whatever that model might be. Okay, so there we go. We've got our session field in here. So this is a foreign key. So then each item that comes in here will be related to the chat session itself. But of course, that's not quite it. That's not the only thing. So inside a SQLModel, we're going to go ahead and bring in something called relationship. So we also want to make sure that the chat session itself has a reference to all of those messages. So we can do messages equals to relationship, right? And this is going to be back populates, and I'm going to call this chat session. We'll come back to this in just a moment. These messages are going to be a list of our chat session model. So that's the data type. Notice that we declare the data type everywhere we go. Messages aren't any different. So I'm going to go ahead and bring in from typing. We'll go ahead and we'll import list. Great. So there we go. Back populates means that when our messages want to connect to it, it will use chat session. We'll see this when we actually query these things here very, very soon. Okay. So this is not actually correct. This should be session ID. And then after that should be session and also the relationship. And the relationship itself is going to back populate. And in this case, we're going to call it messages. This is what the chat will do. So when we actually have the chat object, we'll do .messages. It's the same name as that. And session is going to back populate to chat session. And then, of course, the data type here is going to be simply the chat session itself. Okay. Session ID, session, relationships, all this stuff. So let's go ahead and run our migrations now. We'll run make migrations, and then we've got it's unable to infer the attribute session ID, and this should be a integer. Great. Next up, make migrations, and then we'll run migrate. And I'll just press up a few times. Now, of course, in our database, what we will see here very shortly is a new model, the chat session message model, quite a mouthful. Now we see that there's an ID in here, of course. There's a session ID, content, role, created at, and then finally our chat session. Great. So now all we really need to do is create both of these things. We need to be able to create a new chat session, but we also need to be able to add messages in to that chat session. So naturally, we need to start with just the session itself before we do the messages. We'll do that very, very soon, so you can actually start seeing these relationships form and how they end up working with all the querying and all that. Before we jump into this one, there's a slight correction we need on our chat session model. Has to do with these messages here and what it back populates. This is actually looking for a property on the other model, on the relationship model. So right now that is set as chat session because in a way it's based off of this current table, but that's actually not correct. So if we actually scroll down a little bit, we can see that there is the relationship, the property is right here. It says session, whereas up here we're looking for chat session. So there's two ways to solve this. First off, we can change this to chat session, or we can just change this to session, which is exactly what I'm going to do. I'm going to change it to session so that those relationship fields are now connected to one another. And the same thing is true on this back populates. It's going to look for that same property on the other one. So now they actually do back populate each other correctly. So with this in mind, if you do make changes and you already have database models or something, you could always just drop these old ones in here just like this into your Neon database, of course. You delete everything. Once you do that, you're going to go ahead and run your database migration. So make migrations just to see if anything actually changed. This shouldn't change anything really in terms of the database itself. It's more related to the Python code. But every once in a while, you run into errors like this, and you need to go back and solve them. Okay, so with this in mind, this now fixes something related to that. So we'll go ahead and run our Reflex project once again. And now we're going to go ahead and create chat sessions. This is actually very straightforward. The way it's done is by going into our state. So we've got our chat state, and we've got this onload method. So basically, we want to call this onload method every time we go to the chat page. So inside of our Reflex app, we add the route here. And in this route, what we will do eventually is call that onload method. The actual method itself for the page is also onload. What do you know? So we're going to go ahead and call that based off of our state. So let's go ahead and implement that portion in our state itself. So let's go into our state for our chat state here. And I'm going to get rid of this database stuff for a moment. And we'll go ahead and say print running on load, and that's it. So now that we've got this print statement, let's go into our init file here. I'm going to just do from dot state, or from dot, we're going to import state, and then I'll use this as what I will export. You could always grab the actual state class itself, but I'm just going to go ahead and grab the entire module because I don't really need to grab the state class, and if I have other things related to the state, I might want to use somewhere else. Okay. So now that we have this, we've got this onload method. Of course, I already have chat imported here, so we can do chat.state dot chat state, and without initializing the class, without running it like this, we can actually call onload just like that, and it just works. So now if we save that with our project running, and we go back into our project chat, what we will be able to see is this page will refresh with running on load, and it does it every time you refresh in here. Which is interesting because that should tell us how we should think about the chat state or the chat session state itself. So the way we're going to do this is actually not by using some of these previously done things, but rather we're going to go ahead and create our chat session directly to that model now on this onload method. Okay, so the first version of this will be with rx.session. And we're going to initialize that as, we'll call this DB session now instead of just pure session, because we now have a chat session object that we will have just like that. Now, I'm actually not going to call this chat session for a reason, as we'll see in just a moment, but I will create the object. So we'll go ahead and do object, and then we add it to the database session. We do it just like that. This, of course, is preparing to save it, and then this is going to be actually saving it. So prepare to save, actually save. And I'm also going to go ahead and print out that original object itself. And more specifically, I'm going to try and print out obj.id. Okay, so now that we've got this onload method here, what should happen is when it actually loads this page, we should be able to go into our database tables and see a bunch of sessions being created, right? Literally every time we reload that page. So let's go ahead and refresh in there. We go back into our database, refresh in there, and we will get more loads for those sessions, which might be what you want to do. This is sort of like tracking visits as well. So in a way, this might be good. But we actually don't want to do that. We want to go ahead and do this a little bit differently in the sense that we are going to go ahead and track whether or not our session has a session or our chat session has a session. So the way we're going to do this is by jumping into our chat state. Now I'm going to go ahead and use chat session in here as a property of the state. And by default, it will be equal to none. So with this in mind, now I'm only going to create that session if that is none. So now I'm going to go ahead and say if self.chatSession is none, then we'll go ahead and create a new one. And now I'll go ahead and do self.chatSession equals to the object that comes through. And so if we actually see in here now, when I go to refresh it, now it does create it. It's at 9. It's at object ID of 9. If I refresh in there again, it's still just doing running on load. It's not actually recreating a new session every single time, which is great. That's important. That's exactly what we wanted. Now, one of the things it's showing us is object.id. It actually does have that in there. But to ensure that it has it in there, because, well, we want to make sure that we ensure it, we actually go ahead and refresh our database session object in there just to make sure that that's definitely going to be a database object with object.id. Great. So now we have a way to actually use this chat session, which is going to become important when we actually go and append messages. So right now what I can do is just check that out with self.chat session. And realistically, we'll go ahead and say if self.chat session is not none, then I'll go ahead and print out the ID for it. This, of course, is going to be coming very important very soon. So now if I go ahead and say new message, or once it's done compiling, new message here, exclamation mark, hit submit, we should get a print statement for that ID, and there it is. Of course, I get a response as well, but now I've got this chat session ID, and let's go ahead and say, how about a mesh pots? Let's do some incorrect spelling and see how well it does. But the idea being that it's still 13. It's still the same exact session that's going on here. And so that's, look at that. It does, it does solve the spelling errors too. AI never ceases to amaze me. Okay, there we go. So we are really close to being able to actually store the messages as well related to this chat session. Let's take a look at how we do that now. Now we just need to store the chat messages. This is not going to be a whole lot different than what we've already seen. But let's take a look at how it's done. First and foremost, it's going to be very similar to onload in the sense that we are going to be using this same sort of concept for the chat session. So I'll go ahead and copy this, and we're going to paste it right above append message. This is going to be insert, and we'll call it insert message to DB, just so it's very verbose as to what's going on with it. In fact, it's very similar to the append message in this case, but this time we're going to go ahead and say content equals, or content, and then we'll also say role, and I'll put the default role as the user, or maybe unknown. Let's go ahead and say unknown, just so we have an extra role in there in case we accidentally do not set it. But of course, the content itself we are going to want to use. This time though, if the chat session is none, then we will just go ahead and return this. We'll just assume that if the chat session is none, we should not keep any of the messages themselves. So now, instead of chat session, we're going to use something different, of course, which is the chat session message model. It's quite a mouthful, but that's what we're going to be using. So that's essentially what we have here. But, of course, oops, that's in the wrong spot. Let's bring it down here. Now, of course, this object needs more data in it. So the data itself is going to be related to, well, content and content. And, of course, I need to put some quotes around that one. And then the role is the role. Okay? And so this is going to be some of the data we will pass in to our chat session message model. Now, one of the things about this, though, is we don't need to refresh anything probably, and we probably don't need to do anything with the session either, with the chat session or the database session. We could just leave it as is. Now, there is one other part of this data that we probably want to add. So let's go ahead and take a look at the model itself. In models.py for the chat session, all we did was the content and the role. The two required things are in there. But of course, we also need to have our session ID. We want to make sure that we're tracking that as well. And of course, it's the integer. That's all we really need. So back into our state, we just come in here and we say session ID, and this is now self.chat session.id. And let's go ahead and put a comma here. And that's it. That's how we're actually going to correlate this data together. Of course, we still need to look at it and we still need to verify that this ended up working. But the idea, of course, is this self.chat session being none, we can return it back and we can use this part with confidence because this is a chat session instance. Now, of course, we could also check if is not, or rather is instance of self.chat session of the chat session model itself, or rather if it's not that, then we can return it. But I'm pretty sure we'll be okay with not doing this check. It's just another extra thing on there that we might want to do. Okay, so with this in mind, we now have the data that we want to use. Now we just need to run this. So we'll go ahead and call this now insert data to DB or insert message data to DB. So where are we going to use this? There's a lot of different places on how we can think about this. One of them could be this message right here. I'm actually not going to do that. This is more of like append UI message. So maybe we want to change that name as well. So append message, let's say to UI, right? And so we want to update that in the places that it makes sense. So down here and down here. Next, you might be like, oh, well, why don't we do it in the Git GPT messages? This is also not great either because it's mostly for preparing our LLM response. So I'm going to go ahead and do it right inside of the for method, the handle submit, the main method that's doing this. So right after the append message to UI, this is where I'd actually do it. So self dot and insert message. The content itself is going to be the user message. The role is going to be the user because, of course, it's the bot. And there we go. Or it's not the bot, rather. And then we can do the same thing down here to the append to UI and change this to being system or bot. Either one makes sense. So this actually might be like where, hey, maybe we should make a method that does append message in general, and that one actually does to the UI and the database, because if there's an issue with storing it in the database, we should probably have that rendered in the UI. That's outside the scope of this one, but that's actually probably where I'd do it. I would make just another method that actually handles both of those things at once, and so that's also done in this handle submit here as well. I no longer need those ChatGPT messages to be printed out, but at this point, let's go ahead and take a look at what happens with this data. So now I'm in my chat. I should have a new session going, and I'll go ahead and say, give me some good recipe for yams or something, I guess. I don't know. But here we go. Potatoes, yams, all that sort of good stuff in there. And so obviously right now I should actually have some responses already in my database. So if I go into my database, into chat messages, I did some tests off the video. So I'm going to go ahead and refresh in here, and I can see there is my new session. And of course, there's a lot of different session objects in there, but give me some recipe for my yams. I made a mistake on my insert of that data. I actually did the user message again when I actually really wanted the bot message. So good thing that I checked the database just to make sure that that was happening. And we'll go ahead and do this again. And now, recipe for tacos again. Let's go ahead and submit that. Right away, we should actually have that data already stored in our database. And then we'll get the response back in just a moment. So the nice thing about storing both the user's question or their data and the response is that we can then use this later to make sure or evaluate how well it's responding to some of this content or some of this data. Now, of course, if we wanted to add in a user, if that's something you wanted to work towards, it would actually work basically the same way as this insert message. But of course, it wouldn't just be the chat session, it would also be the user, and then you would just put the user ID in a very similar way. And again, we cover that in the other full stack Python course that basically covers mostly just Reflex. Now we're going to create a button to start a new chat. What that really does is clears out all of the user interface messages and then starts a new chat session in our database. So the way this is going to be done is fairly straightforward. Once again, it's going to be in our chat messages here. What we want to do is I'm now going to go ahead and create a new method called create new chat session. And that is going to basically do this right here. So we'll bring this in and paste it, and we'll put a self in here. And now I'm going to call that on my onload method here. And we'll go ahead and do self.create new chat session onload. Then I'm going to go ahead and do another one called define clear and start new, which takes in self, which once again will now set self.chat session equaling to none. Then we'll go ahead and call a new chat session. We will also go ahead and get rid of the current messages. So self.messages equals to none. And then we'll go ahead and yield this if it's necessary. That's the method that we'll now use. So clear and start new will do that. Great. So let's go ahead and create a button for this on our page, right next to our chat form, or maybe above our chat form where it says chat here. Let's go ahead and create this. I'm going to bring this down to maybe something like 5. And now I'll do rx.h stack. And this is going to be a horizontal stack here. And then I'll go ahead and do rx.button. And we'll do new chat. And there we go. And then we'll go ahead and bring in our onClick method here, which of course is going to take our chat state dot. And this was going to be clear and start new. There we go. So now in here we've got ABC. Let's try this out. And I'll say hello there. Give me a recipe for garlic mash. There we go. So let's see how good or accurate this ends up being. And so what we'll probably see is somewhat of a recipe. That part actually doesn't really matter at this point, right? Because we've got our user interface. There it is. There's my garlic mash. Great. Let's go ahead and do a new chat here. And what do you know? There's my new chat. Hello there. New chat for garlic fries. I can't think of anything other than potatoes right now, which is kind of funny. But there we go. So now if I refresh my chat messages, here's the new session ID. And of course, eventually it's going to respond into our database. Something in there. Let's go ahead and refresh in here. There it goes. It's finally there. Cool. So now we have a way to just refresh our chat. But of course, now we just want to retrieve old sessions that we might have, which essentially will be right underneath our chat. So when we go to a new chat, it would actually show that. Notice that now if I actually navigate around my project here, assuming that things don't refresh, that same chat is still persisted. So this new chat thing is actually fairly important for that process. Now we're going to implement dynamic URL routing so we can actually look up a single session. So we'll do the dynamic URL routing first, then we'll go ahead and do the lookup in our database. So if you go into the Reflex docs, this is actually very straightforward. You go under pages and dynamic routing. You can see that the state can actually use a variable for any given route itself. Then of course we can use that route on the page if you want to. Notice that you can also declare pages with rx.page. We haven't been doing it that method, but the same route idea comes in with app.addPage, as we'll see in just a moment. But one of the downsides of how this works is by default, it actually returns a string. I think that's because of how it's cached. So we do need to make a little modification to that to ensure the correct data type that we're using when we do our database lookup. Technically speaking, it doesn't really matter that much, but I like to make sure that it's type safe in this case. So let's take a look at what this does. First and foremost, the route, the way we're going to use it is in Reflex GPT, where we have this add page method. I'm going to go ahead and create another one, and we're going to define our route right here. I can use the default chat route as the root of the route that we're going to use. So we just use some string substitution in here for that. We put a trailing slash, and then we put some boxes or brackets around it, and you call it whatever you like. In this case, I'm going to call it session ID. This is a variable. Notice that there are brackets in there. And of course, this is well documented also inside of everything with the Reflex docs. There's also catch-all routes, which are pretty interesting as well. That's outside the scope of what we want to do, but definitely worth taking a look at. Okay, so now that we've got this, we should probably consider a different onLoad method. So I'm going to call this on detail load because it's really a detail view that's going to get this session ID itself. Now in my chat route, I also want to make sure that it does have, basically that stuff in there. Now you also might consider in your chat route is doing something like your chat detail route, which you can do the same thing in there and do something like session ID. You can do that instead of what we have here. But the reason I like this is because if I ever need to change the parameters, I can go directly to where it's set, which, you may or may not do. It's more of a stylistic change. These are the ones for static routes that just aren't dynamic because I use the static route in dynamic routes as we see here. Okay, so now that we've got this, let's go ahead and actually add in this on detail load into our state. So chat state here, we're going to go next to the load and I'm just going to create on detail load. And in here, all I want to do is print out self.router.page.params, and that's it. Okay. So if I refresh and make sure everything's loaded up and compiled, I'm going to go into my project and I actually want to go into a chat session that exists because we'll work off of this one. So back into my Neon database tables for chat session message model, we'll look for a session ID that actually has chat messages. Of course, you could look for a pre-existing session as well, but having one that has messages will really highlight this detail lookup that we want to do eventually. So back into our local host here, I'll actually go into /52. Let's just make sure that we've got everything all saved up and it's all compiled. And there we go. So I can actually go to this chat as opposed to doing something like chat B, like that. This would give us a 404 page. Now we're actually routing it and it does actually work correctly. And we can see that the page is being routed or the parameters for it are being routed. So what happens in the documentation is they actually create a variable for this. So we come in and we do var and we could do something like session ID, which would return back a string. So we come in here and we can grab those parameters and we return back the parameter of, the session ID. So we can do get and session ID, or we can have a default value of what we might want. Let's go ahead and just say something like -1. And so this is what you could do then is you could just use self.get session ID of 1. And that actually will give us the correct session ID, which you can see right here. Now, from a database perspective, doing a lookup with this, string, it's actually a string, so we can actually print out the type that it is, self.session ID. When we do a database lookup here, this will still work. So what I'm about to do is not necessary, but I think it's a good idea when it comes to actually using something like a session ID. We want to return back an integer. Now, your intuition will probably be something like, my session ID, and turn this into an integer like this, where you grab it right here. And now I won't have a default value in there, but rather I will have a default value in a try block. So I'll go ahead and do try, bring that one in, do accept my session ID equals to -1, and then we can go ahead and return that. In fact, I'll actually turn it back to being none. Okay, so everything from this, from a Python perspective, this looks like it should return back an integer. And so now we should be getting on detail load an integer, but of course we're not. We're still getting the number, but it's coming back as a string. This has to do, I think, with how it's cached. So instead of doing this, I actually get rid of that and just say get session ID. This now should actually grab the correct session ID, but now it's a method itself. This is no longer cached. So one of the things about this is maybe you want to do it this way or maybe not. But as soon as I do that, it's now an integer and it's the type that I want. Now the reason for this, in my opinion, is so that we can just go ahead and say if not is instance, the session ID itself. So let's go ahead and grab it as a variable in here. So we'll go ahead and say session ID like that. If it's not an integer, then we'll go ahead and return back something different. We'd say something like not found being true, or maybe even something like invalid lookup being true. Like it's not a valid lookup in there whatsoever. So that might be something we would want to end up doing. But again, this part is not necessary for the database itself. You can use either method. I just prefer this method myself. Now let's take a look at how we can actually implement this for our database lookup. Now we're going to actually query our database for our session lookup. So what we want to do here is we're going to define get session from DB. Now it might be something more like get chat session from DB, but I think at this point we probably have a really good idea that that's what we're doing. So it's going to actually be fairly similar to this detail load, but the detail load will actually call it as well. So maybe I still have this instance stuff in here. In my case, I'll just go ahead and say if it is that instance, then I'll go ahead and do that DB lookup. That's pretty much what we want to do here. Now, with this in mind, I could pass the session ID directly into the get session from DB itself like this. So we could do something along those lines, in which case I would do session ID is none. And then if the session ID is none, then I would go ahead and grab that session ID right there. This is more of a fallback, and if I wanted to use it somewhere else. So of course the idea is I need to grab the chat session object that has an ID that equals to the URL parameter. So basically the chat session .id is equal to this right here. That's what we're working towards. Now the way we do this is by using, of course, Reflex sessions, which I'm going to go ahead and import it a little bit differently, and then also SQLModel. Okay, so those two things are what we're going to be using now. To actually get our session data, what we will now do is we will say with rx.session and then as db session, then we'll go ahead and grab our SQL statement. So the SQL statement, if you're familiar with pure SQL, something like select all, from the table. In our case, that table was our chat session. This would give me everything. Now, that's essentially what we're writing right here. We're not executing this statement yet. We're just writing something like that. And the way we write that is by using SQLModel dot, and then we say select. And this will allow us to do our selection or a lookup query that we might want to do. First off, we declare the table we're using. Then we declare the where clause. Now this where clause is to add in the parameters that we want, which are these parameters right here. So this is the statement we're going to use to do our query in the database. So with that query, we got our DB session already. Then we can actually execute a query, in this case, executing this SQL statement here. And then we can decide if we want to get everything coming back or if we want to get one or none. Now, of course, for the chat session itself, we want to get one or none. But if we were doing something a little bit different, let's say, for instance, we were using our chat session message model instead, right? I'll just show you exactly what you would end up doing is you would still grab that same table, you'd grab the session model, and then you would change this to session ID, and boom, now you're doing a query on a different table based off of a related table, basically. But of course, I want to keep it in as chat session, as we'll see in just a little bit when we bring those messages in. But now what we do is we get our result from that. So this will give us back an instance of the chat session model. So basically, we don't necessarily have to say, if not, is instance this of the chat session. That's probably not necessary, but if you did write it, it's not going to really hurt anything because this result should essentially be that. But we don't need to do that, so we're going to leave it out. And all I'm going to do here is say self dot, the actual chat session for the state is going to be equal to that result, right? And so this could be either the chat session itself or none. So it could just go to the default of none. And so what I really want to do is if it is none, I want to go ahead and declare one more thing. And that is going to say something like maybe, did not find or not found, right? So we'll go ahead and say not found. And this is going to be let's go ahead and do the Boolean value. And we'll go ahead and say none to start out. So I'll just change this to an optional Boolean value like that. And we'll bring it in as optional. Great. So now that we've got that, let's go ahead and actually save everything. We've got this, and we'll go ahead and say if result is none, then self.notFound is true. And then otherwise, we'll go ahead and say not found is false. Great, so now we should have our chat session. We should be able to actually add to our session. So the way I'm going to do this, of course, is going back into our detail here. This should actually give us that chat session, assuming that I loaded it, which I did. And so now going into this page here, I should be able to go, hello, give me an ice cream recipe. I hit submit, it adds it there. If I go into my database right now and refresh, I should see that content coming through on that session ID of 52. Hello, give me an ice cream recipe. And what do you know? There's an ice cream recipe that comes back and it is now stored. Great. So now we actually have that data coming through and it's working in a way that you might expect. Now, of course, if the not found is something that we want to also update or see on our page. So I'm going to go ahead and go into my page and maybe just in the heading for right now, or actually next to it, we'll go ahead and do a condition here and I'll do the chat state and then do something like not found. And then I'll go ahead and say, if it is not found, then we'll go ahead and say not found. Otherwise, we'll go ahead and say found and we'll do something along those lines. For now, I'll let you build this out more in the future. But if we change a number in here to like the 51321, we've got not found in there. If we change it to simply something like 52, then we should also see found in there. So it might take a moment for that to happen, which is why we might also want to add in something like loading and all of that, different state elements you might want to do in your Git session from DB itself. That's something I'm going to leave out at this point. But overall, the idea is we can now look up an individual session and add to it. So of course, the thing that was missing in this individual session was all of the other messages you may have sent in there. So the related data. Let's take a look at how we can do that. Now we're going to load in our related data to this chat session. Of course, all of the actual chat session messages. So what we definitely need to make sure that we have in our actual state.py is the chat session message model to be able to do this. Now, there's two different ways on how you could think about doing it. One way would be to do another SQL statement with another SQL lookup, where you actually just grab the SQL statement, paste it in here, and we'll call this SQL statement 2, and then you do chat, session message model, and then chat session message model in here, dot session ID, and then do another query where it's basically like this, where it's result 2, and then you would do something like dot all. And this, of course, would be session 2. And in many ways, this is probably okay. But the thing is, when you have related data, especially if you have it written correctly, you actually won't need to do this. So I'm going to go ahead and get rid of this result 2 and SQL statement 2. Instead, what you could do is you can go into the model and you can see that there is a relationship between both of these models. A little bug we fixed not long ago, but we can see that there's a field in here or a parameter of this model, a property of this model that has messages that are quite literally that chat session message model. They're all instances of that class. So what that means is then in our state, what we could do is this gives us all of our result information. Now what we could do is say our messages, and these are going to be equal to the chat session, the result. We'll just go ahead and say result.messages, right? And even if there are no messages in there, this will actually look them up on the database for us. So we can actually print this out, take a look at those messages, and we'll refresh in here. And what we can see is there's all of those messages. It's quite literally showing them. Pretty fantastic. So of course, the question is, how do we actually load these in to the user interface? Well, we already have something for that, append message to UI. It's just written a little bit differently than the way we stored it in our database. Part of the reason I wrote it a little different than how we stored it in our database was for this very fact. So now we're going to go ahead and do for message object in messages. We want to iterate through all of them, and we're going to go ahead and append it to this. So the message itself, the message text, is equal to message object dot content. And then the isBot message is going to be related to the role. So we'll go ahead and say role. Well, basically, we'll go ahead and start off with false. And we'll go ahead and say if the message role is equal to user, else we'll say true. So a inline Boolean value here. So if this is true, then it's going to go ahead and give us this value. If this is false, then it's going to go to the else clause, which gives us that value. So now I can just go ahead and say message text is that one, and then we can say is bot being that one. Okay, so we don't need anything printed out, but now if I refresh my chat session, we've got this right here. Pretty fantastic. Now, we actually have an issue with the styling. There is a problem that we need to solve, but what we see is the actual data. Now, for those of you who don't fully appreciate how simple this is, I will say that normally what you would have to do is all of these requests here, then you would have to turn it into an API endpoint, then that API endpoint would have to call that data and get it back for us. All of this is just happening in one single function. And of course, what I wanted to do is I needed to actually take that variable and pass it into the message UI. But now what we'll be able to see is all of the messages that are coming through in there, just like that. And now it's actually showing us all of the old ones. And now all of these are context once again to the OpenAI model as well. So just keep that in mind when you do something like this. If you are going to chain messages together, that's what you would do. Now we need to update our state a little bit better, because if I were to navigate around, so like I'm on this detail view and then I go into chat here, the exact same data is still showing up. Now this may or may not be how you want it to function. It's certainly not how I want it to function. So let's go ahead and start off by doing something very similar to like clear and start new, but now we're going to define it a little bit different as clear, and we'll just call it clear UI. And so this one, we'll go ahead and do the chat session being none, the messages being an empty list, and then probably some of our other default values that are up here. That is essentially what we're trying to do here. Now, I probably don't need to have the data types declared here, but I do want to have each one in here as like that. Okay, and so that way we can actually reset our state for any given location. So when we go to clear and start new, we will actually quite literally run clear UI and then start that new session. That way it actually does start correctly. And so on our onload method here, we also might want to call this clear UI right here. As soon as I do that, the chat session will be none. So that's when we'll start a new chat session like that. Now, the reason I want this to always clear on load is because now that's just our root page. This should always be a new session. So we can verify this is working by going to a session that does actually have message data, going back into our chat, going to that home page. It's now creating a new data for me. So if I go ahead and say, hello world, is this working? Something along these lines, submit this. This should be a brand new session for me. And so if I were to go into my database here and take a look at all of the different session models, of course I've been doing testing, but we see hello world, is this working? We've got 118 as our new session here. I can go ahead and take a look at 118, and there it is. But we have another issue, and that is on the detail view. So it's going from the regular chat now to our detail view. What if we actually went into something like our 52, so the other chat session itself? Hey, what do you know? It still has those same messages. So our detailed load has yet that same problem, but it's a little bit more complex. So when I say at this point, this is where we might want to have different chat state based off of the different routes. So I'm actually not going to implement this because it's going to add complexity to an already long project, if you will. But the idea being, if we look into our page here, or our main configuration, we would have a chat list route and a chat list state, and then a chat detail state. You would actually separate these things out. That actually helps us manage our state a little bit better so we don't have too much state going on. But with this in mind, we'll keep this current state and solve the current problem that we have, and it has to do with this on detail load. Now, what we could do is we could just clear out the UI like we just did with our detail view on our list page. So as soon as I do that, then it clears out the UI and then it runs it. But unfortunately about this will actually do a database lookup every single time because of this session itself. So we actually want to add another value in here. We want to change this a little bit more. And we basically want to say reload detail, something along these lines, being false. So I'm going to now go ahead and go off of reloading whether or not the detail view should be done. Now, how do we actually check this? Well, first off, we want to reload the detail if not self.chat session. So if there's not already a session, we're going to go ahead and say true. We want to reload that detail value. And so now I'll go ahead and say if reload detail, then I'll just go ahead and tab these things over, and that will actually allow us to reload that detail value. So now it's basically saying if there's not already a chat session, go ahead and reload that value. Now, of course, this becomes a problem when we go back into 118. I didn't reload the session, but I have all of those original data points in there and probably some new ones in there as well. So we don't want to do that. We absolutely want to reload it when the actual session ID changes from the session itself. So basically putting in an else clause in here. This one has a session. So what we can do then is we can say if self.chat session.id is not equal to the current session ID, then we'll go ahead and do our reload detail being true as well, in which case then our new pages will clear out and then do that reload as well in there just like that. So now we can actually navigate between all of these different pages just to make sure that they're done correctly, which is super nice and definitely something we want to keep in mind when we build out our different chat session and chat IDs in here. So the next and final one might be something like our button, as in like define, create, new, and redirect. This is going to be our new one for creating a new instance or a new chat and then redirecting our page, which is very straightforward. We're going to go ahead and do this return rx.redirect, and this is going to go into our new chat. So I'll go ahead and do this as chat and then whatever that chat session ID would be, which would actually be coming from this create new chat session right here, right? But one of the things, oops, I actually did this off the video. One of the things I might want to do with this is actually return back that object. So I'll go ahead and return back the object that comes through here so that I just have that chat session ID in here. So I'll go ahead and say new chat session is equal to that. And then I can go ahead and return back that chat session ID and redirect it. This will be what I use now for my new button. So we'll go ahead and do our button. We'll go into our actual page here. So we've got our button for this, and we'll do create new and redirect. And let's go ahead and see if this ends up working. We'll go ahead and select that new button, and it looks like it is redirecting us to a new page. Great, so let's go ahead and try that again. I'll go back into my root chat here, which I probably don't need to put new chat in this root chat, but there it is redirected, and we'll go ahead and say, give me a coffee ice cream recipe, something like that. This, of course, will then be able to be verified in our database by taking a look at these different items. There it is. Give me my coffee recipe way down at the bottom there. And there's that new coffee ice cream recipe. Pretty cool. So that is what happens when you start mixing in state, storing things in your database and all that. It starts to make the state a little bit more complicated. As you might imagine, separating those state values out, whether it's listing out things or doing a detail view, probably could save you a lot of headache in terms of dealing with things, but you still need to understand how it works and how you can do it. Now we're going to start the process of deploying our Reflex application, and of course having our Neon database running in production as well. And all of this is going to be done through Docker Compose, and a Akamai Linode virtual machine. But the idea here is once we turn it into a container, we can deploy it wherever we want. Those Docker containers are very, very useful. So I've got a blog post that details these steps, and it's going to be updated as we get feedback from you guys. But the general idea here is we want to go through this blog post to make sure that we can just get everything working the way it needs to. Now, the other thing is the actual GitHub repo itself that we're working on right now will have all of the reference code. So if you find any issues or fixes, go to the issues tab and just do a new issue. You can also do a pull request, but even just writing the issue right in the GitHub repo will be super helpful for all of us. So the idea now is to jump in to this blog post. The easiest way to get here is cfe.sh/blog, and then just look for the deploy Reflex with Docker and so on right on that blog. Okay, so what I did here is I actually created basically a getting started setup. So we've already done a bunch of getting started stuff with Reflex itself. We already have a Neon database. We've got all of that stuff ready. It's already integrated into Reflex and the model itself. So really, we want to scroll down to the containerize your Reflex app. Now, if you're not familiar with Docker containers, what they allow you to do is basically ship an operating system that runs your app already. So in other words, think about our local environment. It's already running. We've got a Reflex app running. If I could just send this entire environment to you, including my operating system, that's essentially what containers do. But of course, we don't want an entire operating system. We only want pieces of it to make sure our application runs. So that's what it is that we're going to be building, is this small little operating system that's known as a container that basically has all of the conditions met to run our application. Now, the reason I'm not saying our Python application or our Node.js application is because containers can run any programming language within them, just like our local computer can. So the way we create containers is by defining a Dockerfile. This is just a bunch of instructions to get to the state that we want it in when we want to run it. So we could do this with our local environment, with our local development environment as well, but I'm doing it specifically for production, which is why I have the Dockerfile named Dockerfile.production. So that's where we're going to start with right now. So let's go ahead and create this on our local project here. I'm going to go ahead and create Dockerfile.production. Now, if you're using VS Code, there's a lot of syntax editing things that you could really go off of here. But the idea is I want to go ahead and update my Dockerfile production with everything inside of the blog post itself. So I'm going to go over this in just a moment. But before I do, I will also copy my git ignore, and I'm going to make something called a Docker ignore, which is essentially the same thing as git ignore. Now, the reason for this has to do with that .env file. We are going to bring in a .env file during the build process, but we don't want the default one. We need a specific way to make that happen. So Docker ignore ensures that when you build a container, it ignores things that you don't want in that container. Our virtual environment, we actually don't want to bring into our container. That's one of the big ones as well. As you can see in here, there's environment stuff related to it that we don't want in there. So going back into our Dockerfile here, what we've got is we've got Python 3.11 coming through. So this is going to inherit from a system that has already installed Python 3.11. So all of the OS stuff needed to install Python, this one already has it, but it also has Python running. Now, in our case, we actually need Node.js as well, because Reflex uses Node.js and Python. I'll explain that in just a second. But the idea is we create a working directory in the container, similar to like our, PWD, this location right here. That is essentially what we're building in the container. Again, remember, it's a small little operating system that we're using here. Then we do all of the necessary installations on that small little operating system to make sure that our project can work. Now, this libpq-dev is important for Linux to be able to connect to a Postgres database in conjunction with the Python scopg file. So this is absolutely important. These other ones aren't necessarily as important. Node.js can be installed in many other ways, but we're just installing it this way because it's one of the default ways to do it. So next up, after all those installations happen, we've got Node and npm installed. Those should work. Then we've got our Reflex user in here, which is this right here. Then we've got some things related to our environment. Now, I actually have changed this altogether. So if I actually refresh on this blog post, I should see a different Docker file in here. So I'm actually going to go ahead and use this different Docker file so the red or those errors go away. Okay, so going back into it, if I scroll down a little bit, I create a specific user on this little operating system called a container for specifically Reflex. And we don't need a password or anything like that. It's just mostly to help with permissions and runtime stuff. That's it. This is fairly, you don't necessarily have to do this, but it is something that is best practice. Next up, we see that we're creating a new Python environment. So inside of the container itself, it's creating a brand new virtual environment. So regardless of how you build the virtual environment on your local machine, this is going to go ahead and create a new one inside of that container. And then it's going to go ahead and put that virtual environment in the path. So the environment variables, I don't need to activate the virtual environment. It will use it by default for Python. So next up, we actually copy all of our application files in here. We have another step here called, move build-env to env if it exists. This step is not something we'll talk about just yet. We'll do that once we deploy this to GitHub Actions, which we're not doing just yet. Next up, we actually set those necessary permissions so the Reflex user can actually run this application itself, which is why we actually built that user up there. Then we switch to that user, and then we run all of the other things in here as needed. So one of the things that's actually important is this initialize Reflex, because there's going to be things that are going to be ignored in our Docker ignore as well as our git ignore. So we actually do want to reinitialize Reflex. It's not going to create anything new for us in terms of how our application runs, but it will make sure that the environment is ready to go for Reflex to run. Then we remove the build environment variable, the one that's coming up here. I'll come back to that later. And we want to make sure that that's removed because we don't want to store any sensitive information in the Docker container either. We want to inject those at runtime, which we'll look at too. Next up, we have some environment variables. These are mostly coming from what I've seen inside of Reflex's self-hosted guide for Docker containers. I just changed it a little bit. And then the final two, mostly this one right here. Notice that we run Reflex a DB migrate and then the backend only. So this is actually showing me that I still need to do something with the front end, because remember, Reflex itself runs both on the front end and the back end. So there's two different things that actually end up running. So that's something we'll need to address as well. But at this time, that's all we really need to talk about with this Dockerfile. If there's issues with building it, that's when you're going to go ahead and jump into those issues right there. Now, if you are already familiar with Docker, you probably skipped some of this part or maybe all of it. You could try to build this container right now. For the rest of us, we are actually going to build this Docker container right inside of GitHub Actions. We will build it and then push it into Docker Hub also from GitHub Actions. So in other words, we don't need Docker installed on our local machine unless, of course, you want to learn more about Docker, which I do recommend. But let's go ahead and take a look at how we can build out this GitHub action now. Before we jump in, I will mention this one's a little bit longer, but it's all about implementing the GitHub Actions workflow to build and push our Docker container. Now, if you already know this super well, feel free to skip this part. Just make sure that you're checking the blog or the code itself to make sure that you have all of the correct things set up so you can actually push your container image. For everyone else, let's keep going. So now that we have that Docker file, we need to actually build our container image. The Docker file is really just instructions on how we can build it. Now, there's a lot of different ways on how you can actually build a container. One, you can do it locally with something like Docker Desktop. That, of course, requires you to install Docker Desktop and run a bunch of commands yourself and memorize what those commands are. In our case, we're going to be using GitHub Actions. GitHub Actions can build containers for us and then push them where we want them to go. So you got to think of the container like it's its own operating system, where if you build it, you need it to be pushed and hosted somewhere before you actually run it. We'll talk about that in just a second. But the idea is GitHub Actions will actually build it for us and then push it into a place where it can be held, which is Docker Hub. Now, when it comes to actually building your containers, you can push it into other hubs, into other container repositories, much like we push our code into a GitHub repository or Git repository. We can push our containers into a container repository. After it's in a container repository, our deployment options can download it from that container repository to then go ahead and run it on where we end up running it, which we'll see once we do that process. Right now, we just really need to build it and push it into Docker Hub. Owning that process, I think, is really, really liberating, because then you can decide how you build it and where you push it to after it's built. In our case, we're using Docker Hub, but there's a lot of different options out there, including you can actually build your own version of Docker Hub if you wanted to. But of course, all of the major cloud providers either have one of these things or will have one of these things on their own. So with that in mind, let's go ahead and start the process of building out our container image with GitHub Actions. Now, of course, back into this blog post again, if I scroll down, I can actually go all the way down to my create Docker Hub repository and token, but then more importantly, the GitHub Actions workflow, build and push Docker image. This is what we're going to end up using. So I'm going to go ahead and copy this. It needs to be at a very specific location on our repo, which is in .github/workflows/build.yaml. Now, if you ever forget this, you could always go into your GitHub Actions on any repo, and you'll see there's this getting started thing. And if you just click on one of them, it will actually give you that same path. And yeah, you could even build this right now and just commit it to your repo. That causes potential issues. Do keep in mind that a lot of times you'll see YAML as YML. I like doing it as YAML. Old habits die hard. But the idea being that you want to make sure that it's that correct path. So back in my repo, or the actual blog post here, I'm going to go ahead and copy this, and we'll bring this into our local file. If I just copy that whole thing, it will make the folders for me and also build.yaml. So then I can actually just copy the file itself and paste it in. So now we're going to just walk through what's going on here, and then we will actually push it into our repo and update a few things. First and foremost, giving it a name. No big surprise here. Workflow dispatch. I'll talk about that in a second. The push command, where it actually automatically builds everything or runs this actual GitHub Actions workflow. That's what's happening here. This is how the workflow actually runs. These are called triggers, but the idea is when we actually push our code on the main branch, which is what we're doing, as you can see down here, you can actually declare which paths will trigger this workflow to run. So in our case, we've got our Dockerfile, we've got compose.prod.yaml, which we don't have yet. We've got our requirements file. So basically, if anything changes into these paths, the GitHub Actions container will run. We'll see that in just a moment. Next up, we've got our environment, our default environment. Now, in this case, I actually have the container I want to use. So this is the destination where we're going to build our container image and push it to. It certainly looks like a GitHub repo, but it's actually a Docker Hub repo. So I'm actually going to change this to being based off of secrets, and then I'll comment this one out. We definitely want to change it off of secrets, as you'll see in just a moment. Next up, we actually run the build and push. So what happens here is it's going to run on Ubuntu, a Linux machine itself. It's going to be a containerized version of that machine. Then it's going to go ahead and check out our code. That is our entire repo. That's what's going on here. These versions might change, so just keep in mind that they do change. And if you ever want to know what version you should use, you just go to github.com and then do, github.com and then / and then whatever GitHub action you are using. So if you go there, there's the checkout action, and then, hey, what do you know? Version 4 is out, so we can actually change this to version 4. Next up, we use build X. This is just another GitHub action to set up Docker, so we can actually run and use it. We log into Docker. This is what's happening here. Notice there's a couple more secrets in here. Then we're going to go ahead and build a env file, or .build env. These are the secrets we need to actually build our Reflex application inside of our container. We'll come back to this again. Then we actually build and push those items. So we use the Docker command to build it based off of our Dockerfile and also the environment variable for our Docker image, which is, whatever our repo is going to end up being. Then we actually tag that image, then we push it. So building it, tagging it twice actually, and then actually pushing it into the GitHub repo, and then we remove that build env file. Okay, so what we need to do is we need to set up various things related to this. Now, the way we're going to set this up is going to be one by one. First off, in our .env, we need to make sure that this actually matches this right here. So in other words, I want to go ahead and bring in my OpenAI key here as well and bring that in just to make sure that my build environment matches my development environment to some degree, because eventually we will remove this. Now, for those of you who are like, wait a minute, this is going to go into the actual Dockerfile itself, I want to bring back the idea that we bring it in here, but right here we actually move that .build env to a .env file, which is what our Python decouple is looking for. Then we actually run through the app and all that, then we remove that file. In other words, we don't store our sensitive keys in here. They're just injected during run or during build time, and then they're removed also during build time, which is exactly what's going on with these keys right here. So we shouldn't be exposing these keys unnecessarily, is the point. Okay, so now we actually need to bring in this build file to GitHub. Of course, the way we do this is by going into our source control or git control, and then I'll go ahead and say added GitHub build workflow. Go ahead and commit this, and we'll sync those changes, and this will just push it into my repo. Okay, so back into my repo, into GitHub Actions. I'll go ahead and ignore this old repo file. It starts to actually run this code. So it runs these steps. It'll go one by one and run everything that we declare in the job name, and then all the steps in there. So what's going to happen, of course, is it will fail because I can't actually log in because I actually don't have username and password. So that's the first thing that we need to solve. The way we solve this is, of course, logging in and creating a Docker Hub account if you don't already have one, because this is going to be our first secret. That's these things right here. Now, I do have a secret up here in the environment, but it's not actually being used until later. So I don't necessarily have to do that one first, but we'll do all of them right now. So the first one is going to be our Docker Hub username. So you could obviously grab this from Docker Hub itself, and it's literally that right there. So whatever you put that as your username, that's what it's going to be. Going back into your GitHub Actions under Settings, we want to scroll all the way down to Secrets and Variables into Actions. Once again, Settings, scroll all the way down, Secrets and Variables into Actions, and then you've got Repository Secrets. Not environment secrets, but repository secrets. This is what GitHub Actions will use by default. So we go ahead and add a new one. I'm going to give the same name as, secrets dot, and then whatever's next is going to be our username here. And again, going back into Docker Hub, if you aren't sure what your username is, just go ahead and grab that one and then come back into our actions and save that one right there. Great. So the next one is going to be our Docker Hub token. So let's go ahead and create a new repository secret. I'll put that token in there, and then we need to actually add in a secret here. Now, whatever you put here doesn't actually matter because you can always change it. So if you ever need to change it, that's how you do it, what I just did. So now to actually get this token, a real one, we go into Docker Hub. We click on our account settings. So in your account dropdown, account settings, this location has changed, and it might change over time. But basically, we want to find a personal access token here. And I'm going to go ahead and select it. We're going to generate a new one. We need to make sure that it's read and write. In my case, I'm going to call it the Reflex GPT GitHub Actions token, read and write. Great. Now, the actual production token, the one we use at runtime, we might use read only. But in our case, we need read and write because we're going to create a container and then we're going to write it to Docker Hub. We're going to push it into Docker Hub or upload it there. So we need read or write. So we're going to go ahead and generate this. And this label already exists, so I'll go ahead and say to or whatever. I'll generate this and I'll grab the token that comes through right here. Notice that there's a username right there as well, but I'm going to go ahead and grab the token and we're going to bring this into GitHub Actions. Go ahead and update the secret. Great. So now I've got a token and a username. We still have one more thing related to Docker Hub, so we might as well do that now, and that is our Docker Hub repo. Notice that there's the Docker Hub image and the Docker Hub repo. The reason I'm calling it the repo in the secrets is so that we have a distinguishing value for the repo versus the image, so I can talk about both of those things. So I'm going to bring in the repo here, and then I'm going to come back into Docker Hub, and I'm going to grab the repo I want to use. So jumping into Docker Hub and hub.docker.com, these are the repos. So you can create a new one right now, and you can call it Reflex GPT. I'm just going to call it Reflex GPT-2 for a moment, and I'm going to go ahead and say it's private. I'll go ahead and create it, and there we go. So now I have a private repo in here. Private is important for deployment. I do not recommend having your deployment repos public, unless, of course, you know exactly what you're doing, which in our case, yeah, we might know what we're doing. We also might not. But this is going to be the repo itself. Now, I'm going to go ahead and grab that repo, and I'm going to bring it into my action secrets and paste it in here. Now, in my case, I'm actually not going to use the -2 here. I'm just showing you exactly what needs to be done, but the idea is this is going to be the repo. It looks identical to GitHub, and in fact, in my case, it is identical to GitHub. It is identical to this GitHub repo right there, which is really nice because it's a lot easier to find these things. So I'm going to go ahead and add this secret in and save it. Okay. So now is the time to go to the next part, which is going to be our 2 different secrets that are in here. Because I do want to build this one in just a moment. So I'm going to go ahead and grab my OpenAI key. I'll add it into my repo secret here. I'll go back into my local environment or .env here and actually grab this whole thing. I'm going to get rid of those quotes. I don't want those quotes in there anymore. It's not necessary. In fact, it often can create bugs. So I'm going to go ahead and add that key in. Feel free to create a brand new OpenAI key if you want to. And then I'm going to go ahead and get my Neon database connection string in here as well. And I'm going to go ahead and add this one in also with database URL and paste that in and add that secret. Okay, so at this point, I have all of the environment variables that I need for my Reflex project. Now, if you have more in here, add them right now, and then also add them into your create build env file one by one like we just did. Okay, so now that I've got all of this, my environment variables are all set up and ready to go. I can actually jump back into GitHub Actions, and I can click on the workflow name itself. I can always pin it to the top because it's something I'll continuously use. then I can run this trigger of run workflow. The reason I can run this trigger of run workflow as a one-off is because of this workflow dispatch here. I can also comment all of this out if I want it to be a one-off where I manually run it every single time. I don't actually want to do that. I want it to run automatically on its own so that it actually starts to build out the container image itself and then pushes it. Okay, so now what we will see at the very bottom of this build.yaml file is why I actually changed the name from Docker repo and Docker image. So the Docker Hub repo is the Docker image. That's going to be the same thing. But the idea here is the repo itself is a little bit different than the image because the image often has what's called a tag with it. So in my case, I am tagging it 2 times. I'm tagging it with the tag of latest, and I'm also tagging it with the tag of the GitHub commit SHA. So we actually have the commit in here as well. Basically, it's going to be corresponding to the current state of the code as it stands, and then we go ahead and push everything in there. So in other words, our actual image, we can actually change what we end up using in production based off of how we tag that image. And then once it is all said and done, it's going to be in Docker Hub, and we can go to the repo itself. We can look at the tags that are in there, and we can see all of the various tags. Naturally, I've been testing this stuff out, so you can actually see the state of the actual code is related to the actual tag that we use in here. Now, you can change these tags as you see fit. You can also change them as your own, GitHub Actions settings. So if you were to come in here and you want to do like something like my production tag. So for example, we did our prod tag and we wanted to do something like V1001 or something like that. You could then use that tag to be another one that you actually build out. So you would come in here and you would just bring it down and do something like secrets dot and then this prod tag. And then you could kind of have an idea that this is going to be the production tag itself that you want to use. Now, there's a lot of different strategies on how you can actually use these tags and the way you might want to use them. Something I'm not going to go over right now. But the idea is at this point, with all of those credentials correct, we can build and push in about a minute. Okay, so what we've got here is we check out our code at v4. We build, we use Docker build X to install Docker, make sure that's working. We log into Docker Hub with the username and token. Then we go ahead and build out that env file with all of our different environment variables. Then we are going to start the build process with the specific Docker file that we declared, which of course brings in that build.env file, changes it into a .env file so it can actually build everything as necessary. And then once it's built, it then goes ahead and starts to push those container images as well. And it all happens in a few steps in this one right here. Then it removes that build file. And then what we would end up having is right inside of Docker Hub, we should be able to see a new tag for our recently built container, which is this one right here. That would have been like a minute or two ago. And there we go, 2 minutes ago, it actually finished. So now going forward, to actually build this container and push it, all we need to do is change our code. GitHub Actions will automatically build it for us and automatically push us. And it will also let us know if that fails, in which case we just go into the workflow itself and we diagnose the problem. So at some point your token might expire, in which case maybe it says invalid login, it can't log in or something like that. Or you use the wrong repo or the wrong GitHub, or rather the wrong Docker repo. You use mine or something, it won't let you do that unless you have permission, of course. So yeah, it's actually pretty neat on how this all works. Granted, it can get a lot more complicated than this, but I wanted to make sure that you understood all of these things because the next part, when we actually deploy it, will sort of build off of this, but actually getting the Docker container correct is what's most important. Because now that we have the container correct, all we really need is the .env to be injected to run the container at runtime when we need to run it, which is what we'll do in just a moment. Let's take a look. When it comes to deploying to a virtual machine, we have to use SSH keys. Now, it is possible to do it without SSH keys, but it's not a good idea because we want to automate this deployment process as much as possible, especially when things go wrong and we need to bring things back up really, really quickly. So the idea here is we actually need to create an SSH key pair, a public key and a private key that we will then use exclusively in our GitHub repo. So we actually need to understand how to create these things, which is exactly why I have this blog post and why it was recently updated, was to help understand this process. Now, if you've never done this before, it's going to be really important that you go through it and understand it and get it working. If you have done this before, then do keep in mind, we want to make sure that we are using a brand new SSH key only for this repo. So if at any time we need to delete it or remove it, it doesn't affect anything else we do with our default SSH keys. And we are also going to go ahead and try this out by deploying a virtual machine on Akamai Linode. So go to linode.com/Justin and you'll be able to get some credit for your account, and you'll be able to start your own virtual machines. Now, this process works on all cloud providers that provide virtual machines. If they actually deploy your containers, that's a whole different thing. If they actually use virtual machines or remote servers or remote hosts or virtual instances, there's a lot of different terms for virtual machine, or like on AWS, they're called EC2 instances, but they're all virtual machines. They're all servers that you rent through the cloud. They're kind of that building block or that layer that you need all across the board. So it's actually fairly straightforward and very, very common on what we're about to do. So for that reason, let's go ahead and jump into this blog post and start this process. Now, again, we're going to generate a brand new SSH key pair. So this is actually a really important thing to understand. We're building a brand new one so that we don't interact with some of our other SSH keys. So inside of your terminal window, you could even do this on PowerShell if you're on Windows, or of course I recommend WSL. The idea is SSH should be already installed by default. Now, SSH-version doesn't actually matter because SSH is so common that it's just installed on most machines. Mobile phones might not have it, but the idea being that SSH is for a secure shell. It's just like your terminal window, but the terminal on that other machine. It's like you're logging into that other machine's terminal. That's the point here. So what we want to do is we want to actually take a look at our different SSH options. One of them is SSH keygen. If I just hit enter, it's going to attempt to create an SSH key for me. This is not the actual correct type. So what I want to do is I want to use the type of RSA. So I can do -t RSA, and now it's going to try and create an RSA key pair, and it's going to try and do it in this location. Now, I've done this many, many times, so if I hit enter, it's going to ask me if I want to overwrite the default one. I don't want to do that. This is the reason this video exists. It's because we want to use a custom one. We want to do it and save it inside of our current project so that we can test it locally before we put it into GitHub. So the idea then is I want to store it in here. So once again, I'm going to go ahead and call this command. I'm also going to go ahead and make sure that I add in the bytes that I want to use, and then I'm also going to go ahead and add in my own email in here. So I'll go ahead and do -c, and I'll just do hello@teamcfe.com, which is an older email that we have for Coding for Entrepreneurs. But the idea is this is how I'm going to generate this key. I hit enter, it's going to try to generate it again. I don't want to override anything. Instead, what I want to do is I'm just going to call this my Reflex GPT, just like that, the same name as the folder I'm in. So the important part here, if I hit Control-C, PWD out, I see that I'm already in this project, right? This is where I want to store it. If you weren't already in this project, you would need to have an absolute path to where you're going to store it. So back to that generation, I'm going to go ahead and create it right in this folder here, and I'm going to leave an empty passphrase. Adding a passphrase here is nice for more security, but it makes it harder to automate things. So it's kind of a trade-off to just not have a passphrase, basically. And there we go. So I now have a key, and it's stored in this local project. Now, if I open up VS Code again, I can actually see those keys in here. Right off the bat, I want to make sure these never go into Git, as in into my version control. This is not how we're going to use them on GitHub. So I want to go into my source control here, and I want to add both of these things to git ignore right away. Great. So now that we have that, let's actually take a look at these keys. So reflexgpt.pub, this is your public key. All of this is your public key. This is what you can actually share. This is what you would put on a virtual host of some kind. In fact, we could do that right now if we wanted to. But before we do, I want to take a look at the private key. What do you know? This one says private key. Simple enough. Basically, the private key is your password. It's a long one. It's more complicated than what you might be used to, but this is definitely your password that you'll end up using in terms of connecting to it. We'll see this in just a moment. So right now what I want to do though is grab this public key. I'm going to grab it and I'm going to go into my cloud provider. Again, you can use any cloud provider out there. Linode just makes it really easy. DigitalOcean makes it really easy. There's a lot of them out there that make it really easy to install your SSH key. So inside of Linode here, I'm just going to go into, hey, what do you know? SSH keys. I'm going to grab this one. I'm going to create a new one. This label is going to be my GitHub Actions SSH key for Reflex and GPT is what we called it. I'm going to paste in that entire public key, the whole thing. You need to make sure you grab that whole thing. Now, on the actual blog post itself, I actually have a command to make sure it's a little bit easier for you to copy the whole thing if you make any mistakes, which is really easy to do. So if you scroll down here, you will eventually see copying the public key. This is how you can copy it on Mac and Linux, and this is how you would do it on Windows. But basically, you would replace this path with the absolute path of your public key itself. And again, it's got to be the public key. Once you actually have that, you'll be able to use it once again. So I'm going to go ahead and put it in here as my key. I'm going to go ahead and use that. We will add this key. This is now in my Akamai Linode account. So what I'm going to do in the meantime is provision a new virtual machine. What I'm using here doesn't actually matter that much at this time, but I'm going to go ahead and use Ubuntu. I'm going to use a region that's somewhat near me. I'm going to go ahead and use Seattle, and I'm going to use shared compute. I'm going to use the cheapest one that they have, whatever that might be. Just grab that one. The details of the label don't matter that much at this point, but we'll put Reflex GPT. Notice there is a root password. This actually does matter. And then I'm going to go ahead and use my SSH keys for my account. Notice that it has a bunch of them in there. The public keys, we can install as many as we want. That's totally okay. Now this root password here, we actually want a password that we will use. So I'm going to go ahead and use OpenSSL for this. And it's going to be ran base 64. And we'll go ahead and do 32. That will just give me a password. A lot of different ways on how you can generate a password. Feel free to go online somewhere. There's one on you can use a Python one as well. But whatever you use here, you want to make sure that it is a good password. The nice thing about a lot of cloud providers is if you turn off your virtual machine later, you can always reset this root password itself. You may or may not be able to install SSH keys after the fact, but you should be able to install a root password or update that one because it's very critical. Anyway, so at this point, I now have a virtual machine I'm going to go ahead and create. I'll just let that run, and I'm going to go ahead and not save that password. But here's a SSH command to log in. Now, in my case, I actually already have my local SSH keys installed here. Now, in this case, what we want to do is we actually want to use the recent one that I just added, the Reflex GPT. That's the one that I want to use to connect to this. So the way this works is we run SSH-I and then whatever our private key is. That's the key part here, is our private key. So no .pub, just our private key itself, and then we use root at whatever IP address we have. This should absolutely work. We shouldn't have to use that recent password I created. In fact, I might actually bring it in here in case I do have to use it. If I do have to use this password, that means I did something wrong in the SSH installation process, and I'll show you a reference that you can use to install it. Okay, so Linode usually doesn't take very long to actually provision your virtual machine, but I'm going to go ahead and let that finish before I try to log in. You could try right now. It's probably going to just time out, or it's just not going to actually connect. So we'll come back when it's actually ready. At this time, it is now running. It's up and ready to go. I'm going to go ahead and try to connect again. So in my case, it looks like it was about to time out, but it didn't do it just yet. Now, when I connect for the very first time, it's going to say, hey, do you trust this fingerprint or the authenticity of this host? Because we've never connected to it, our system, our local system, doesn't know about this. So this becomes important later when we actually deploy this with Ansible, as you'll see. But for now, we're going to go ahead and just leave it as is. I'll go ahead and say yes, and then I can actually deploy on here. I'm actually on this virtual machine now, right? And so that's the key part of all of this, is now that I can actually connect with this public key and private key, I can now have confidence that I can use this on GitHub. So before I go any further, what I want to do is I actually want to jump into my GitHub repo. I'm going to go into my settings here, and I want to actually create my key. So I'm going to go into secrets and variables. I'm going to go ahead and create my new keys. I'll do my SSH and we'll call it the public key. And here I'm going to go ahead and actually put in my SSH public key. I'm going to just copy the whole thing and paste it in. Should look exactly like that. And if there is anything with the spacing, so in my case, it actually looked like it grabbed some spacing. So I'm going to go ahead and exit out of here. And I'm going to do that cat of the key itself. And then I'll go ahead and do a pipe pb copy. This will give me the exact copy of what I need. And then I'll come back into my public key here and I will paste that in. That might have the same thing, it might not. Of course, if you change these keys, it might ask you for your password, which I added in off the video. The next one is going to be our public key, or our private key rather. Once again, I'm going to go ahead and grab it the same way. This time, I should be able to add it in as a repository secret. This is going to be my SSH private key. And that's it. So now these are in the repo itself. So GitHub Actions should be able to connect using a very similar method that you might on your local machine. Now, we're actually going to be using Ansible and those keys to do the automation for the installation. But the idea then is once we actually go to SSH in here, we're going to need something like Docker. Docker needs to be installed here, and Docker Compose. Both of those things need to be installed here. So in the case of ours, we actually want to keep these keys for now. I'm going to keep them local for now so that I can actually use them if things go wrong with Ansible, but also so we can actually just verify a number of things that GitHub Actions is going to do for us really, really soon. So that's it for this one. The blog post itself goes into more detail with some of these things. And if you ever get stuck and you need to manually install your key, the way you do that is right here. So you can install it with this. You can also use the copy command. Once you actually do it with the actual key itself, you will be prompted for your password, and then you can actually add in that key. That password, again, was this one right here, right? And so there's a lot of different ways on how you install it, but the idea is once it is installed, it's going to be added into your cat SSH and known hosts. It's going to be in here. The most recent one is the one I just used. I can remove this at any time. You can actually even delete the entire known host thing if you want to. I have a lot of known hosts in here that are no longer relevant to my projects. I got a lot. Oh my gosh, I got to delete this thing. But the idea being that that known host file here is how it's going to keep track of what services or what hosts that you can connect to and what it's also looking for, like what SSH key you used to do so. So that's another thing. So feel free to go through that. Once you do install this on your virtual machine, the virtual machine has a version of this as well. So if we actually log into our virtual machine and we go into the SSH, we can see that there's authorized keys. So these authorized keys are going to be any given public keys you might have in here. In my case, I have a few public keys that are already in here because my Linode account had a few keys in there as well. So that's also something else to note. But at this time, it's actually time to start implementing these things in GitHub Actions. If you have questions on this, please let me know. And if you find any errors on the blog post, I want to make sure that this is done right so all of you can actually get down into using the SSH keys. If you want a lot more depth for SSH, please let me know as well, because there's something else that's really cool inside of VS Code is you can actually use VS Code to SSH for you. So you can write code in your remote host directly, much like it is with your normal VS Code instance. It's really cool. But if you want to see more things on SSH, please let me know. Otherwise, let's take a look at how we can automate the setup process on this virtual machine for our project. Once again, this section is a little bit longer because we actually deploy the application into production using Ansible and GitHub Actions. So we have a lot of things to talk about. Now, of course, all of this stuff is in this blog post. So feel free to go to that blog post if you want it to go a little bit slower and more deliberate in terms of how things happen. But overall, I try to make this as approachable as possible without being way too slow and way too much about any given tool. Let's take a look. At this point, we know the process to create brand new virtual machines along with our GitHub Actions or disposable SSH key. So it's time to actually configure this for our project. This is going to take a couple of things that we haven't really talked about so much just yet. But the first thing is I want to grab the public IP address. Now, knowing that if there's any issues with this particular virtual machine, since it's a smaller one, we might need to upgrade this to the next level, which was like $10 a month, but basically doubling the RAM to make sure that that's all working. But I think this should work okay. Let's give it a shot. First and foremost, we'll go back into our Reflex GPT application here, and I'm going to grab that IP address and bring it into my GitHub Actions here. We'll paste this in, and then I'm going to go ahead and call this my virtual. Let's actually double check in the blog post itself. I'm going to scroll all the way down to our virtual and machine IP. There it is right there. So that's what we want to call it, because in our actual dispatch repo, we see that it's in there as well. So we'll come back to those things in just a moment, but I just want to make sure that I have the correct IP address in there as it sees fit. So one of the things we actually haven't done yet is the Docker Compose side of it all. So I actually skipped this on purpose because I wanted to come back to it. So in the blog post itself, underneath the Docker, container file, we actually have the Docker Compose file. So let's go ahead and see Docker container, or Dockerfile rather. And there's the Dockerfile. So right underneath this, we should see our Docker Compose file. Here it is. So I'm going to go ahead and copy this, and we're going to bring it into our local project, and it's going to be compose.prod.yaml. It needs to be the same name for just, as you'll see in just a moment. But the main idea here is we have build commands for the Dockerfile production, but these build commands will not use the environment variable file. So we actually still need to do it the way we did with GitHub Actions. If you wanted to use the build file locally, if you wanted to try this out locally, just keep in mind that we called it build-env inside of the GitHub Actions, which you could verify inside of your Dockerfile as well, that we look for build env to use that in our build process. Now, with this in mind, I see that I have my particular image. You will need to change this to your particular image, and you need to do that now. Now, what we see here too is a front end and a back end. So we've got the front end and the app. So the front end is going to run this command. The app itself is going to run the default command, which is in the Docker Compose file in production, which is going to run migrate and reflex run env prod and backend only. So Docker Compose is really important for this reason. Now, the other part about this is the ports that we're using. So when we actually deploy this into our virtual machine, we are going to be basically running it at the exact same ports on our Docker containers, both containers. So there will be two containers because of Docker Compose. So two applications running. The actual port 80 is how we'll be able to access this from the internet. That's going to be mapped to the front end port of 3000, which of course is the default. And then the back end port will be at port 8000. And then again, we'll also be running at 8000 on the local machine as well. So port 80 is the key thing here as far as actually making sure our application runs, as well as your actual image. Now, you could actually build this Docker Compose file on the fly, which I'll show you where that's going to happen in just a little bit. But now what I want to do is I want to create a new folder, and we're going to call it DevOps. And inside of this folder, we're going to go ahead and bring in our playbook. So going back into the blog post for this, we're going to go ahead and search for the Ansible stuff. So I'll just go ahead and do a quick search there. And there's my Ansible playbook. I'm going to go ahead and copy this, and we're going to go ahead and bring it in as playbook.yaml. The naming here is going to be important as well. There's several things about this that, are particular to this project and using Ansible. Ansible can get really complicated real quick, or it can be really easy. In this case, I think it's fairly easy, but if you've never used GitHub Actions, you've never used Docker, and now you're using Ansible, it's going to start to feel maybe a little overwhelming. But the idea behind Ansible is it's very similar to GitHub Actions and Docker files in the fact that it's basically just a bunch of steps that need to happen to actually be ran somewhere. So it's just configuration. It's infrastructure as code. But the idea for this one is it's going to go on specific hosts, on specific virtual machines that we'll set up soon. It's going to be the root user for that. It's going to use some variables in here and variable files, which we still need to bring in. Then it's going to go ahead and install Docker, download the Docker install script, run the Docker install script, and ensure that it's installed and running. So those three steps right there is how we can make sure that Docker is installed on our virtual machine. That's it. Now we could do this manually as well by downloading this script and then running it that is definitely possible. But the reason we do it in Ansible is that we can run this as many times as we want. Similar to like GitHub Actions, we can run it as many times as we want. The difference is that GitHub Actions is actually going to run this playbook for us, as in it's not going to run on the virtual machine itself. GitHub Actions is going to run it, and it's going to run it on the host itself, which is why we have this as well. Now, we could use GitHub Actions as just pure SSH to run all these things, but Ansible adds another feature that we'll see in just a little bit. Next, we create a destination project directory, really where we're going to store our compose.prod.yaml. That's really the key file that we need to bring on there, as well as our .env file also. So what we see is we actually only copy the Docker compose file and the env file. Then we log into Docker Hub. We do this using Ansible, very similar to like what we did with GitHub Actions, but we need to do this on our virtual machine as well because our container image is private. If our container image was not private, we would not need to log into Docker Hub on our virtual machine. We could just use the public image itself, which is pretty nice. After that, we actually pull all of those container images using Docker Compose. Then we actually update all of the different services that are in there. We try to do this as gracefully as possible. It's not that graceful, as in there will be some downtime, but this will limit that downtime as much as you possibly can with just purely Docker Compose and not something more robust like Kubernetes or Docker Swarm or Nomad. Next, we actually remove all of the old containers if there are some of them, and then we prune our Docker system. So all of these commands are fairly straightforward in terms of setup process itself. The magic of all of it comes down to just simply running Docker Compose itself. So Docker Compose and then up is essentially what it is that we want to use, which ends up happening down here as well, and also in the detached mode. So Docker Compose.prod.yaml is a key part of all of this in making sure that that works. Granted, you could give it different names if you wanted to, but that's essentially all we're going to be doing with Ansible. Now, yeah, we could learn a lot about Ansible and we can do all sorts of things, but hopefully this gives you a little sense of Ansible itself. Now, the next thing is the actual workflow for Ansible itself. To actually run Ansible, we need to do a few things. So I'm going to go ahead and grab the workflow file itself, and we want to put it into our GitHub Actions again. This one is just simply deploy. I'm going to go ahead and copy this one and paste in here. Now, this one, I'm going to use it as a one-off tool. It's going to only run when I actually tell it to run versus every single time. I think that's actually fairly important to make sure that the build command finishes and then we can run it. Now, there's ways to chain that in GitHub Actions. That's outside the scope of this one. But the idea is we've got our Docker image here. This one, I'm not sure if we will even need on this at all. But I do have it in there in case those of you who are a little bit more advanced inside of using Ansible and building out different files, you could totally do that in your deploy option. So what we see here is, once again, it's checkout version 4. That's the modern version. Then we can actually install Ansible directly into our Ubuntu command. This is a Python package, but this is one of the ways you can install it as well. So there's a way to install it with pip install Ansible 2. Both ways actually technically work, but the reason we're doing this is then we don't actually have to install a bunch of things related to Python as well, which you might actually end up having to do. Next up, we need to set up our SSH key. Hey, what do you know? There is our SSH key, that private key that we have so that we can actually do the things that we need to do with SSH. Next up, we actually grab and add our virtual machine to node hosts. This just helps us make sure that we don't need to add it to node hosts. This may or may not end up working super well for us. We'll talk about that in just a moment. But the next thing is we create our Ansible inventory. This is creating an inventory file that will have Linode at the very top. We will see this in just a moment. And then our virtual machine in there with our root user. The reason it's root user is because we have to use root at the virtual machine, whatever that IP address ends up being. And that, of course, comes directly from, Linode itself, root at. If this was different, then we'd have to change that right here. Next, we create our env file. This is going to be our production environment variable file. So all of the production env needs to be in here. There's a chance that we need Docker Hub and the Docker username in here as well. More than likely, we won't need those things, but just add them just in case. This will be injected into our actual final virtual machine. So this will actually update it, or this will be updated based off of Ansible itself, and it will be a .env file also. So then we actually create the Ansible variables file. This variable file is what Ansible uses instead of .env. Ansible can't use .env, or or at least there's not a clean, easy way to do it. So what we do instead is we create devops.vars, we create it inside of this folder, and it adds in our Docker Hub token and our Docker Hub username. Both of those things are referenced in here. So if we actually scroll down a little bit, we can see Docker Hub token and Docker Hub username. Those come directly from that vars file, which is what is referenced here. So that creates those variables for Ansible to actually run them. Then we can run our playbook. Notice that I have Ansible host key checking being false. This right here makes sure that we don't check the SSH key and the host. That is something that this is also attempting to do. So both of those things are there so that it doesn't stop in its tracks because we haven't verified the host yet. And then this is actually how we run Ansible with the inventory file. It's going to run DevOps, that folder, /playbook, and then it's going to run all of those things. Notice the extensions are all the same. Now that we've got that, let's go ahead and add all of this into our GitHub repo. So I'm going to go ahead and clear this out. GitHub, git add -all, git commit, and Ansible plus deploy. And then we'll go ahead and do git push. Okay, so a lot of things can go wrong here, but hopefully all of the things that I did in this project will make sure that this actually ends up working okay. It ends up working well for our Ansible project itself and for Docker Compose and all of those things. Now, if you have to do this stuff manually, you totally can. Just keep that in mind. So this right here is actually building the container. It's not actually running the deploy here. But we do actually want to run the deploy. I don't actually think I'll need to actually wait for the container to finish at this point, mostly because I already have a built container and that one should already work. So what this is going to do now is run Ansible for me. It's going to install Ansible, it's going to set up our SSH key, and then it's going to go through that whole process. While that's working, what I will also do is I'm going to go into my local project here, and I'm going to go ahead and grab the variables. So let's go ahead and grab this vars file. I'm going to go ahead and do this basically the same thing. So in DevOps, I'm going to go ahead and do vars.yaml. I'm going to paste this in here, and we're going to go ahead and tab these things back a little bit. Okay, so the reason I'm doing this is so that in my git ignore, I could add these vars in here, because we don't want to commit those at all. But now I could actually test this locally if I wanted to. So once again, the actual tokens, we'd actually have to get the token values and put them in here. Something I didn't do off the video, but you'd want to grab your token and your username. Now, the reason I would do something like this, and the reason I actually do this, is because then I can actually run this Ansible playbook inventory. Now, of course, that also means that I need an inventory file, which I can make as inventory.ini. And the way that file ends up looking in the end is Linode, the IP address, and then the Ansible user, which again was, if we scroll up a little bit, we can see that it's basically this right here into the inventory file. Right, so that's what's happening, and we will see the final one in just a little bit. But the IP address, whatever that IP address was, we would put right there. And that's the inventory file that we would use. And once again, I'm going to go ahead and add this into git ignore because I actually don't want to bring it. So that would be if you wanted to test it locally. So what I see on my GitHub Actions is it is working. It seems to be working right now in terms of installing everything. At the very least, it's running the Ansible playbook. It didn't error out right away. And so what we should see is our inventory file in here. This is in just the GitHub Actions. It is not on the virtual machine at all, only GitHub Actions. It actually is hiding the IP address, which is really nice. And then it actually runs through everything else. And then GitHub Actions or the Ansible playbook is then run to install Docker, to do everything. It looks like everything is working okay. It changed everything. I didn't get any failures on here with Docker itself. So the only thing I really need to test at this point is that it actually worked. It's actually live on my project. So let's go in and grab the IP address, the public IP address. It's not looking like it's working yet. So let's go ahead and try something here. We'll go ahead and do SSH root at this. Now, I actually already have the SSH keys local, so I'm going to go ahead and use the ones that we all have, which hopefully we all have. And it's going to be SSH-I, the Reflex GPT. Let's go ahead and do SSH-I and Reflex GPT. And then we'll go ahead and grab the root command in here, which was this one right here. I don't actually want to copy that whole thing, just part of it. There we go. And so now I'll try to SSH in here, and I'll do Docker Compose PS. I don't actually have anything. Well, if I actually navigate into the app, I can see there is where compose.prod.yaml is. Now I can do docker compose.f, and we can actually see this, and then do .ps. Looks like everything is running. So what I should see now is in my IP address, hey, what do you know? There it is. Let's go ahead and give it a chat. I'll go ahead and say, hello world, are you working? And I'll go ahead and hit submit. Hello world, are you working? Hey, ready to be there. This responding means a couple things. Number one, it means that yes, OpenAI is working. Number two, it likely means that our database is working as well. So jumping into Neon, we can actually see this. So if we log in, go to our project, go to our tables, and then go to our chat messages. You could delete all of these messages if you wanted to as well. I'm just going to go to the, looks like we don't have that many, so let's go back. And we don't need this offset. Okay, so I have, hello, are you working? Looks like it's there. So let's go ahead and try that again with our deployed app. Where did you go? There it is. Let's say, give me a taco recipe. Hit submit. Give me a taco recipe. Go back into Neon. Take a refresh in here. And give me a taco recipe. Fantastic. So there you go. You now have a deployed version of Reflex on a virtual machine, and it's going to be $5 a month to make this run as far as the virtual machine is concerned. Your database is probably going to be free for a while. OpenAI might be a few bucks for all of the different things that you end up generating, but for probably less than $20 a month, you now have this thing deployed. Now, one of the challenges that you would go from here would be to have a custom domain name and have stuff like, Nginx running so you can actually have HTTPS in there. But that's definitely outside the scope of this one. The point of all of this was to get us to the point where we could deploy and do it well and repeatably. So if we actually rerun this workflow, this will deploy it again, and it'll just keep doing it until we make changes or we're satisfied with those changes. And so you could try that now. I do recommend that you do it. It's actually fairly straightforward. Now, the last thing I would challenge you on is to deploy this again, but just by using the Dockerfile itself. Like, find hosts that will deploy Docker containers. What you'll need to do, of course, is connect the front end and the back end. So you'll need to run two containers with two different commands. But that's really all you would need to do from here going forward. The Ansible of it all and the virtual machine of it all may or may not be how you want to go and host it. But as we can see, it is working, and it's working pretty well. Hey, thanks so much for watching. Hopefully you got a lot out of this, and thanks to Neon for helping us bring this course to life. Now, the idea from here is to actually bring your application to more places. How can you deploy it with other deployment options? Now, the reason for that is so you can be resilient to any platform change you might need, especially when it comes to using something like Ansible. Maybe that's far too complicated for what you want, so you want to just deploy your container somewhere. But since we do have a container, we should be able to deploy it anywhere we want. And also, since we are using Neon and it is managed database, it's actually really easy to not only deploy it somewhere else, but then to branch things and just really test out the entire environment in another deployment option with a few clicks. It's pretty neat. So that's it for this one. If you have any questions or you want to see more things with Reflex or Neon or Docker or SSH, please let me know in the comments. I would love to hear your thoughts and see what it is that we need to build next. Thanks again for watching. My name is Justin Mitchell. Look forward to seeing you next time.